Tere hommikust kõigile veel kord. Mul on hea meel teid nii arvukalt siin näha. Ma usun, et paljud mind tunnevad, aga keda ei tunne, ma olen Kalev Koppel, Onnineni päikseelektri juht. Ja täna me kogunesime siia, et siis tutvuda lähemalt meie ühe suurima kinnitustarvikute tootja K2 toodetega ja täpsemalt, et õppida ja aru saada, kuidas kasutada nende arvutusprogrammi viis.
So good morning everybody, my name is Matjaž Grošelj. I've been working at K2 for 12 years. I have prepared a presentation for you and hopefully you will get as much benefit as possible. I have divided up my presentation in 3 parts. Initially, so first part will be a few words about K2. Secondly, I will show you some poor installation practices that I have collected throughout the years. And finally, the last part will be the product overview. So we do plan to show you to use some K2 base software, as some of you probably know it. We do have some server problems at the moment, so please let me know they're fixing it. When if you're online now, let me know so that we can jump in and start using it, because for me it didn't work at the moment. So please give me a heads up, give me a green light if you see that you can use K2 base. We are still waiting also for the samples. They're being laid, so hand samples. They should be here in an hour maybe. In terms of English, so this will be in English. Please, if you don't understand anything, Kalle will help me translate it into Estonian. Before I kick it off, I would like to ask you a question. So how many of you have already used K2 base? If you can raise your hands, please. So the majority. How many of you have already used K2 products? 40% maybe. So this, I have only one presentation. Some of you are very experienced. Some of you are less experienced. So I have to somehow balance this. So for those who are more experienced, please be patient. I also have to talk about stuff, that are more appropriate for beginners, or if not beginners, for people who are beginning and starting in this industry. So we have to do a little bit of everything. So it might be boring for some, but please bear with me. So I suggest we kick it off. So this first part is a few words about K2 Systems. So who we are, just like you. We are passionate about the energy transition. We want to achieve it. And we do this by developing installation-friendly mounting systems that are tailored to your needs, so to the needs of installer. And we also get ideas from you. So we get a lot of ideas from installers. A little bit of K2 history. So how did we start? This is a young industry, but K2, let's say, is not that young in the young industry. So K2 was founded in 2004. So we have now almost 19 years. And this is a lot, again, in the young industry. Where we are today, so we are on 10 locations on 5 continents with our daughter companies. We work together with more than 120 distributors worldwide. And K2 has, at the moment, 420 employees. I forgot to mention, so please feel free to jump in anytime, ask a question. I prefer it better than just having a monologue. So if you have questions, just jump in. A little bit of statistical data so that you, for those who don't know us very well, get an idea who we are. So So far, they have used our products, our systems, our solutions in more than 130 countries. We have so far supported more than 24 gigawatts of PV modules with our mounting systems. We have sold 10 million single rails, for those who use it, single rails, which is, as you see, enough to twice the circle of the Earth. So it's a lot. A lot of quantities going on, 400 megawatts weekly at the moment, but it's just skyrocketing, you know. The markets are incredibly strong and booming. The demand is enormous. So we are, you know, seeing this year shipments of over 1 gigawatt every month. So practically, as you also probably feel it, the demand from the market is higher than the capacity. And this gap makes a little bit longer delivery times. So the global markets for solar are booming, really, really strong. Almost 400,000 projects have been implemented with our, you know, solutions so far. 15 millions of roof hooks sold, which is, as you see, as heavy as an Eiffel Tower. This is pretty much what I have mentioned now. So this is the growth. The growth is enormous. We have last year shipped almost 8 gigawatt. We plan with 13 gigawatt for this year of mounting systems. So the growth keeps powering forward. Base users, as you know, we are not offering only a physical product or a solution, but also we try to develop top-notch digital solutions. And one of them is the mentioned K2 base software, which has already almost 30,000 users. This is a lot, especially if you consider the fact that we sell companies, not private people. So, and this has been growing tremendously. As you see, 2018, less than 4,000 users. We are approaching 30,000, and this year shooting above 30,000 users. So this is really a lot. We're proud of it very much. K2 is still a medium-sized company, you know, at the European level. So in terms of the supply chain, 85% of products are being made still in Europe. Although we are also sourcing outside Europe, this is now 15%. It might grow a little bit because there is not enough aluminum production in Europe. So aluminum as a metal, you know, we use only aluminum, right, for our products, is incredibly energy intensive. So, and if you have a, let's say, an energy crisis on this continent, then you don't produce as much aluminum. First of all, you don't have the capacity. Second of all, you are not competitive price-wise because you have an energy crisis. And if you see our end product, more than 40% of the cost that you buy of the end product is energy. So it's tremendously important how the energy picture looks like. So, you know, this share European towards outside Europe sourcing of aluminum might change. Yeah. Any questions so far? Please. Yeah, so we are focusing now only on rooftop segment. We believe we have the highest market share in the rooftops in Europe. We estimate about 20%. Yeah. We have pulled out a little bit of ground mounts because this is our specialty. K2 is known for expertise in the rooftop. So, yeah. How we work, so we have 3-stage distribution channels. In terms of the residential market, so these are households, right, that buy from you. We do this strictly through distributors like Oninen, but larger projects, so industrial, commercial, We call it CNI, so CNI market we also do directly. But it has to be a bigger project. So usually those large projects, they don't get supplied out of a warehouse, so from a distributor. So we as K2, to sum up, we are kind of the interface between the buildings and the energy production. So that's why our motto is we connect strengths. So we do this, as I mentioned, also by not just developing mounting systems, but also offering you digital tools so that you can increase your productivity. I have planned, to work a little bit with you on K2 base software. So until we fix the server, and we get online, we will improvise a bit. So it will be a work in progress. So if you notice that you can get access, please let me know. So mounting systems, our philosophy, K2 philosophy, is always to develop easy to install, very fast to install systems. The idea is that you as an installer spend as little time as possible on the rooftop. The workers, are missing in this industry. So the workforce, the labor force is missing. So you have to have products that are easy to install, fast to install, and move on to the next project. So we also, as I mentioned, get a lot of ideas from you because you are the ones installing this. We at K2, we have our own R&D, so research development department in Europe, USA, and Mexico. We also cooperate with research institutes, Building Aerodynamics Institute. For example, for flat roofs, this is the case, where we test our flat roof solutions in the wind tunnel by the principle of car industry, and then we see, and we monitor how the system behaves blowing the air through the wind channel. So we give 12-year warranty. This is standard. It can be extended, of course, up to 20 years. But 12 years is a standard warranty. Back to the digital solutions. So those who have used K2 base, it's now in Estonian language, of course. The norm is still not integrated. So the Estonian norm, so you still have to use the Eurocode. The Eurocode is the standard at the European level, how you have to calculate this. But the Estonian norm will also be integrated inside. But this just only means that at the moment you have to enter manually the wind speed for Estonia and snow load for Estonia. So once the Estonian norm will be integrated, because it uses Google Earth application, our software, the software will immediately know and detect by the address of your project how much snow and wind speed you have to consider for your calculation. So for those who are new, to K2 base, what does it offer you? Offers you, first of all, the layout. You can make the layout. It's Google Earth supported. Material specification or bill of materials you get, including the price, and structure verification. So what is structure verification? Is my system strong enough for these, conditions? Conditions like wind speed, snow load conditions for this country, building height, and so on and so forth. So every project basically must be structurally verified, statically verified, so by Eurocode norms. That's why we have this. So we have 5 steps, to get to the results: bill of materials, and structure verification. Of course, the layout we will show you how to do. It's also very easy. We also have the connection to some of the main inverter manufacturers. As you see, SolarEdge, SMA, Fronius, Coastal, Goodby, and Archelios is an energy yield calculation software. It's just the interface, and it enables you time saving, because when you enter parameters in K2 base, these parameters are transferred into the software calculation software of the inverter producers. So you don't need to re-enter the parameters twice. So K2 base, then another tool, digital tool for you that you can try is the K2 Docu app. As the name suggests, this is documentation app. And you as an installer, you have a lot of different parts of documentation. So K2 base is one. And then you have dimensioning of inverters document. Maybe you have PV Sol, you have energy yield. Maybe you have AutoCAD, maybe you have feasibility study. You have a lot of different parts. And K2 Docu app enables you to automate documentation, organize it section by section, add new sections, and then at the end also to add signature of yours, so sign it. It is synchronized with K2 base. So if you haven't tried it yet, please have a look at that as well. So as I mentioned, so they're both synchronized. The changes that you will make in K2 base will be, of course, also made in the K2 Docu app. So, have you already tried Docu app? Can you raise your hands? Nobody? Okay, nobody. So maybe this is a chance that you now have a look at it. Okay, I will now share some of the poor installation practices with you now. Perhaps you can, comment this with me. We start off and then it just gets better and better. And funnier also, so. Maybe you can comment with me. What's the problem here? It's pretty obvious, but this is throughout Europe, so many European countries. So this is like more a shading problem. Same project. These are non-standard solutions. I have to emphasize we do a lot of non-standard solutions, and K2 base enables you standard solutions, calculations. So everything what you have and is not standard, you send to us. We will calculate for you. But K2 base will offer you, enable you 85% to cover your needs. 15% roughly will be out of the ordinary, some customized solutions, and this we do. So this is one of such, non-standard customized solutions. Here is the problem, obviously, with shading. Most of these pictures are not K2 solutions, but everybody else is. Maybe one is ours, which was planned in a wrong way. What's the problem here, maybe? Any comments, any ideas here? Any ideas? Yeah. First of all, you go over the edge, and the modules are not in raster. They're not in symmetric fashion. So the modules should be always in symmetric fashion. Well, yeah, and also material reasons. I mean, aesthetical reasons as well. Yeah. In terms of the edges, in this case, because these PV modules are portrait and the rails go horizontally, it's not such a big issue, but it doesn't look well. But if you had modules in landscape, it would be a problem because you wouldn't be able to use the rails. Yeah. So this is pretty much the same problem. There's a lot of improvisation in the industry, but less and less, now the industry is maturing. But most of the mistakes happen when people don't use the software, they don't structure, verify their system. Or they use a cocktail of different components. Like they buy something from us, something else from another, and they use a cocktail. Third, if they use a software, then they feed the software with the wrong parameters. So this is the responsibility of us users to feed the software with the correct parameters, because the software doesn't know whether you feed it with the wrong or correct parameters. So it doesn't know that. So you still might get wrong results if you feed it with wrong parameters. So these are primarily the reasons why mistakes happen, apart from the fact that some people are still improvising. So this is supposed to be a flat roof, as you see, different levels. Usually you have to discontinue and start over when you have a slope, right? So you can see this is not a good installation. Here, too close to the obstacle, packed, a lot of shading, a lot of obstacles. Some of them, like these cabling management problems don't have to do with us, but I'm showing it to you. Obstacles as well, so another shading problem, so you can see here clamps, they are not fitted, correctly. They are not, in the channel. Like here, not tightened enough, stuff like this happens. And then you can see this, what do you think here is the problem? Speak up, please, I didn't hear you. Lack or too many? Lack or too many? You said lack, Yeah, okay. There is no middle clamp, yeah. Too many clamps. Actually, you could solve this problem with just one clamp, so. Yeah, this is creative work, so. Experimentation. One middle clamp, would be just enough. Here again, not, sitting properly tightened. Membrane roofs like bitumen and PVC. So here you can see it's not protected, These systems are ballasted, and when the wind is blowing, they are shaking, vibrating a bit, rubbing against the surface. So this is very dangerous because sharp edges will dig a hole in the membrane. So you have to be careful with such stuff, Roof hooks, we have different roof hooks. As I will show you later on, we also get the samples. There are all sorts of roof hooks in the market, very cheap ones. But, you cannot structurally verify them. Cheap, in terms of roof hooks means little material. So the bracket is like this, and the thickness of the bracket gives the strength to the roof hook. And of course, if you have a cheap roof hook, you have a thin bracket. But you won't be able to document such a cheap roof hook with the software because they're just too weak for, let's say, snow and wind conditions in your country. We also have cheap roof hooks, but they are not appropriate for locations with high snow load, very fast wind speeds, So at the end of the day, it's not about price, but whether you can verify this project or not. So this is very important. And you can see here, when you have a too weak roof hook, wind pressure, snow pressure, whatever, snow load, pushes it down, the tile will always break, almost always if it's too weak. So this happens a lot. So of course, we need to, pay attention that we use optimized material and affordable materials, but still, see that it's still a structure verified project by the software. by any software. So in this case, ours, but there are a lot of Chinese products, but you cannot verify them in terms of strength. So this I feel is very important, for me to emphasize. Stuff like this, you can see many times, if you don't use adjustable roof hooks, so adjustable in height, many times you need to place a piece of wood underneath to make the height higher, but it has to be waterproof, right? This is the project. It looks terrible, so it has to be a waterproof wood piece, that you use. So in this case, you can see it's a catastrophe. So, do you work with roof hooks? How many of you have already used roof hooks? If you raise your hands. Only 2? Nobody else works with roof hooks? By the way, these are tiles. So these are households, residential market. Yeah. But nobody raises hands. Okay, so this gets more interesting now. What do you think happened here? Maybe here, if it's more illustrative, Yeah. Why do you think the frame got opened here? Why do you think this happened? Well, could be. We don't know, but could be. But it doesn't necessarily have to be the main reason, right? What else? Any ideas? Because this is really interesting. Well, it could be, but probably not the main reason. It had a contribution, probably. Yeah. Many times installers make a mistake by removing snow guards. And snow guards are a basic function of the rooftop. And PV, so photovoltaics, have to adapt to basic functions of the roof, not vice versa. So snow guards have to be there. If you have to do something with them, shift them maybe a little bit back and forth, but don't entirely remove them, because the snow will, maybe 200 kilos per square meter, slide forcefully down with the ice and open your frame. So this happens. We see that. So please don't remove the snow guards. Also, it happens that, snow slides down and it falls on the cars. Or if it's a school, it falls down on students, all sorts of stuff. So basic function of the roof has to stay by basic function of the roof. So just leave it there. Okay. Any questions? So these are more, customized projects that you cannot design in K2 Base. As I said, K2 Base are standard solutions. We will do this for you, but you have to be careful. If you do this alone, you make sure you have a proper calculation behind it. So these things like to fly away from the rooftop, They really do. Wind is more dangerous than snow. It acts both ways, pressure and pull force. So snow is just pressure. That's why we are offering you, it's for free, our, top-notch software. So, what do you think here is the problem? Yeah, here in this case we have another problem, that it wasn't checked by those who had a contract with the investor if the roof itself is strong enough. So it collapsed inside. So, okay, another good example. So here, hanger bolts. Why did this happen? Where? Wood. Yeah, this could be one reason. Maybe another one? 5 degrees is okay.
This is added hook.
Sorry?
That is added hook.
Edit hook? Yeah, but could be, but the main reason.
Because they are not connected, those panels between like two panels from the middle. I think but I don't understand.
They have middle clamps. Maybe the screws are too weak, right? Too long or too weak, you know. And that's why you have the software, that you verify it, you know. Is my system strong enough?
Are also not, they should be more in the middle of that module.
Yeah, could be, but I think it's the main reason. The main reason is the screws, the hanger bolts. So you have a lot of pull force by the wind, you know, and if they're not strong enough, they will collapse. So flat roofs. Now we'll talk more about flat roofs. You know, such stuff doesn't happen very often now. It did like 5 years ago and more, because flat roof solutions are the youngest in this industry. And there hadn't been enough experience, you know, in terms of how they will behave just being ballasted. But this is old. Maybe it happens now here and there, but not very often. You can see, you know, this is terrible. It's experimentation, improvisation. Not standard industry solution. Look at this, how this is sealed. So this is not a PV industry standard. So, you know, we are the most underestimated part of the PV. So everybody feels that they know everything about mounting systems, because everybody feels that it's enough to be an electrician. It's important to be, but you have to know about mounting systems a lot, you know. The biggest mistakes are here, not in the electrical part. And this is how it is. So here you see a clamp, right? It's bent. This is what the wind forces can do. Experimentation, you can see there is not even ballast there. So flat roof solutions are ballasted. This is the most legendary. So somebody cut off a piece of a bitumen layer and stuck a metal sheet below, thinking, yeah, it's going to work, you know. Probably, you know, this picture is old. This is not on the rooftop anymore. It's probably flying around. Right? Like this, for example. So, you know, they really like to fly away. I'm saying it to you. I have pictures now that are coming that are a few months old, you know. If these are not standard solutions, you know, if they're made in some workshop without a calculation and verification, it happens. This one is a little bit older, right? But I have now, following a few month old installations flying away. Not a standard solutions, you can see, you know, triangles and some strange elements. This will happen, right? It is very serious. So ballast, as I mentioned earlier, you know, at K2 we use wind tunnel testing. This is Aerodynamic Institute. It's by the principle of car industry, just like the car industry does it. You put a mounting system into the tunnel, blow the air through it to see how it behaves. And the values that we get are now in K2 base, so we calculate ballast very accurately. You are on the safe side. But you have to feed the software with correct parameters, like building height, wind speed, snow load, and so on. And then you can be pretty sure that it's okay. This is 1 year old. This is the only picture with K2. So The problem here was they calculated, but use wrong parameters, not enough wind speed, wrong building height. Building height is very important. The higher you go, the more ballast our software will calculate for you, because it's more exposed. Of course, the height is important. And also, the terrain category by Eurocode, which we'll be talking about a bit later, is also extremely important when you are entering. You have, PV modules flying on other PV modules, damaging them. Usually this stuff is insured, right? Insurance companies. But the insurance company will want to check whether you have a document by Eurocode standard to insure it. So if you have it, they will cover the costs, right? So you need to have a document. Like I said, the relevant document on the EU level is Eurocode norm, and the calculation is based on the Eurocode norm. So very important. And there it goes, There is no even ballast here, so I don't know how long this stayed on the rooftop. But it's easy, super easy, for the wind to move this stuff. Across the city. Yeah, across the city. Maybe this one, just watch this one. It doesn't happen anything, but what do you think here is wrong? No ballast at all. This is one. It's a very good one. Yeah, no windbreakers. That's true. You can see the size of the profiles. What do you think about the size of the profiles here? Yeah, but it's about hits, wind gust. It stops it, What do you think about wind profiles here? They look so thin, yeah, so weak. So this is probably improvised solution. So it's not like full-scale, large-scale production or development behind it. Also, the inclination you see, it's not standard. The PV industry now has it on the flat roofs as a standard 10 or 15. So 15 max, 10 or between 10 or 15. But not more. This is because of the aerodynamics. We saw that if you go above 15 with inclination, the ballast will rise exponentially, not in a linear way, but exponentially. And European buildings are not designed in the way that you could place enormous tons of ballast. So there is also this limitation, in terms of how much ballast you can place on the flat roof. So for those who have used K2-based, so far you could see that our calculation is very detailed. And you can see how much weight per square meter and in absolute terms we place on the roof additionally. So this is in the document when you print it out from base. You can see easily, how much ballast per square meter and how much the whole system, including ballast and PV module and mounting system per square meter, we are placing on the rooftop. All this data you get calculating in our software. More of improvised projects on flat roofs. So stuff like this. Has anybody seen this before? Or first time? It looks nice, right? Yeah, this is 2 months old, this one. This one is the newest. Yeah. I think it happened after being 3 weeks, after 3 weeks of the finish of the installation. So, Yeah, it's good that you have insurance, but either the investor will not, pay you again for buying new PV modules. So that's why my presentation is focused on spreading the awareness. How important is the calculation? The groundwork is very important. So because when it comes to such situations, it could be €1 million monetary loss, and yeah, the investor is not at fault. Who is at fault? We know about this. Okay, going back to maybe tiles. Any comments to this? Roofs are not always symmetrical, flat, even, so it's good to use the adjustable roof hooks to adjust the height. Also, you can see the clamps, right? Here are 2 clamps, and here is one, and here is one. So there is no clamping range. And usually when you go landscape like this, the rails go in this direction and not that direction, because you clamp it on the long sides. So here, another installation. You see a hole there. Maybe something fell on it, Here you have a double layer, which wasn't really necessary, if you ask me, so too much material. This is more with fire, it doesn't have to do with mechanical part, which is us. So tiles again, if the roof is too old, I don't know if it makes sense to go through with the PV. This is more for you, if you're an electrician. Cable management issues. Doesn't look good. Lightning protection. UV protection. Equipotential bonding. Do you do equipotential bonding here in Estonia? Do you use the yellow green option? Yeah. We have a product called TerraGrief, which goes underneath the clamp. It's like a clip, a very small metal piece, but can be done this way as well, as long as it doesn't corrode. So we offer this equipotential bonding, but it's perfectly fine if you use your own solution, because it's more electrical. You can see corrosion. So this is pretty much it in terms of poor installation practices. Any questions so far? Okay, folks, are you back from your coffee break? So we talk about poor installation practices, where the biggest mistakes happen. Professional installation, so the key is the building survey, as you know, the measurements, so that you can do the layout and verify the project. If you go inside into the structure, roof structure, you have to know everything about it. Are you dealing with the wooden structure or with the steel one? That's a big difference. The spans, so the spacing between the purlins and so on. Is there any insulation? In terms of hanger bolts, you need to know is there any insulation between the structure and the wave to decide about the right length of the screw. So everything starts with the building survey. The next parameter that you need to enter still in K2 base before it's integrated with the Estonian norm is the snow load. As you can see, it is significant, different regions, different snow loads. So this is something we need to enter properly. So you can see this varies from 2 down to 1.25 kilonewtons per square meter. So this is one parameter very important. The second one, I couldn't get the data like the official document from your country, but I could get some data and I could see that it's the same in every major city. So this 21, if you have different information, different data, a document which is official like the previous one, please let me know, but this is what I could find from the Lubal database. So this is pretty easy to remember if it's true, if it's correct. So wind speed needs to be correctly entered. This is not all, so this is just an entry, right? So the final wind load will be calculated by our software because this is just wind speed. And the final wind load will be calculated by the software based on building height, and terrain category. So we have, by Eurocode standard, 5 terrain categories. As you see, coastal area, this is the worst. You will get the highest loads. Flat field with hedges, suburban, and urban area. So urban area, I advise you to use conservatively, only if you're like deep in the city center, like here. Otherwise, don't use it, just use suburbs, which is in this case free. And for 2, 1, and 0, you will anyhow know. So coastal region is up to 5 kilometers away from the sea. And 1 and 2 is also obvious. So the lower you go, the worse it gets. So altitude is already recognized by the base software. Building height is very important that you enter correctly because the final wind load will depend also on the building height. The higher, the more ballast, for example. Parapet height, which is a little wall, as you see. This is parapet. Flat roofs have parapets, so to hide all the obstacles, AC devices. They designed them this way. But this parapet is actually a bit above the rooftop surface. Also plays a role in terms of ballast. Roof pitch, of course, it's important. On flat roofs is important in terms of whether it's flat or not. We'll talk about this. But on pitch roofs, the pitch is important because of the snow load. So, and of course, roof type and its understructure. So, as we will see later, you will decide whether you want to go into the skin, so the rooftop covering only, or inside into the roof structure. So if you go inside, things get more complicated. You need to much more, many more stuff about the roof structure and the spans and so on and so forth. If we do a quick exercise, maybe for ballast, let's say that we are talking about flat roofs. And we take building parameter, building height. So if I increase the building height, how will the software calculate for you? So ballast will go up or down? Yeah. You will do an exercise later. You will see how this behaves. Parapet height. Okay. Okay, wind speed is pretty obvious, so this will be the main parameter. And of course, terrain category will be extremely important, what you will choose. So we have from 0 to 4. If we go up from 0, the ballast will. You are for down? Who's for up? You're for down. Who is for down? Not everybody, so it should go down, yeah. Significantly, we'll see that. And of course, number of PV modules in one group. If you connect more PV modules into one group, how will the ballast behave? You're for down? Everybody else? Up? Who's up? You're up? Anybody else? You're up? And what about others? Okay. Yeah, because they resist the wind as a group together. So you have to, if you can, connect as many as possible. They hold together, right? Type of roof membrane is important. So these, have different roof membranes. On the flat roofs, you have PVC, which is like most standard, the more whitish, think, and you have bitumen, which is quite popular. You have concrete, but PVC and bitumen are the most common, and PVC obviously is the most sleepy. It has a low friction coefficient. And bitumen is much better. It has higher friction. When I say friction, so this is also what we need to enter into base, is the interaction between our system and the surface membrane. Yeah, it's more sleepy. So we'll talk about this later. But just so you know, it does play a part in the amount of ballast. When you calculate, you have to know which kind of membrane you're dealing with. This is pretty much for flat roofs, but for pitch roofs, the roof pitch is important, and the structure of the roof, like those two last pictures that you see. Different stuff, a little bit different stuff than on flat roofs. Okay, if we do the product overview, we will start with pitch roofs. We'll do the overview of solutions that we have on the pitch roofs. We'll talk about that, and then flat roofs will be the last section. And this is also where we'll try to do some exercises. So we go now into the world of roof hooks. So not many people raise the hand. So you all use roof hooks, right? Let me see if these are all. If you have any more. Yeah. So we have different roof hooks. We have two types, so aluminum or steel. And what is the difference? The difference is, of course, the price. The steel roof hooks are cheaper because they're weaker. They're not as strong as aluminum roof hooks. Then the difference is also that some roof hooks are not adjustable in height, like this one, right? What gives the strength to the roof hook is the thickness of the bracket. So this is 8 millimeter. It works perfectly for Estonian snow and wind conditions, right? When you decide which roof hook you're gonna use for your project, beside the price, you need to check, which roof hook will be verified and documented that is strong enough, beside the fact which roof hooks are in stock, right? There is also one difference, that all aluminum roof hooks, are attached with single rail family. Well, we don't. I think we have single rail. which means from the side. So this is single rail. It has a chamber here, and it is connected with this climber, so like this. Whereas the steel roof hooks just a second, are always connected from the bottom, not from the side. And this family of rails is called solid rail. So the aluminum roof hooks are attached laterally from the side with single rail, and steel roof hooks from the bottom via solid rail. Okay, so for those who are more new to this, we always go with 2 screws anywhere, here or here, here or here, per roof hook, and always on the rafters. So the rafters are the vertical beams, right? The main beams. And what you need to know, obviously, it's very important, is the span between the rafters. This is what you need to enter into K2 base. So if this is the rafter, and the next one is in 1 meter, so the next roof will be here, and the rail goes like this. So the more you expand the spacing between the rafters, the stronger the rail you need to bridge between 2 points. So that's why I need to enter this, and it's an important parameter. This is the most popular roof hook. It's called cross hook 4S. So this is the same, but it has a climber. So with the climber, this is cross hook 4S. It's very popular because it's strong enough and it's very adjustable. You adjust the height here and here 3 times, 1, 2, 3. And you can also adjust it horizontally, left or right. So you can go a little bit on the side of the rafter, you know. This doesn't need to be in the middle of the rafter. So cross hook 4S, yeah. I'll show it on the next slide. Maybe you can pass it on here. So, and to make it faster, you go. Yeah. So these are aluminum roof hooks. You can see. So this is the single rail. Attached from the side. So, and you have also like a combination. You have a 3S, which means 3 times adjustable, but it doesn't have adjustability on the bracket like the 4S that you're holding in your hands. And then you have a single hook, which is also more basic, but just as strong, a little bit cheaper. So it depends how you would like to work. So there is no cookie cutter answer. So some installer will like adjustability. Some will not care and will say, I'll take the cheaper one, but it's just as strong. So it depends also on your preferences beside the price and technical stuff. So one important issue with all systems is the thermal separation. So you cannot, connect as many rails as you want, because of the thermal expansion of the material, of aluminum. So we have different rules, and this is stated in our documents, assembly instructions, when you need to discontinue connecting the rails. In this case, it's after 18 modules, and then you make a 15 centimeter break. It's almost with every system a little bit different in terms of this rule. Yeah, but this is not with roof hooks. It's for trapezoidal metal sheet. We will get to that. Yeah, it's earlier there. Yeah, it's eight modules. Yeah. So the K2 base will cut it. Will stop connecting the rails. But sometimes you have to optimize this. We will show now how to do this. So because it will discontinue for only one column of PV modules and it doesn't look good. So we need to optimize in base and put the thermal separation in the middle of the group. It looks better, and from the standpoint of stability, it's also better. So K2 base will consider this, but it's important that as an installer you follow and you do the thermal cuts as well. So it's not enough that we just design it with thermal cuts, but it has to be installed this way. Okay, maybe we watch a video for those who are just encountering, roof hooks for the first time.
Hi all, my name is Willem and today I'm going to show you the single ray system with the crosshook 3S and 4S for clay tile and concrete tile roofs. In my hands I have the crosshook 3S. Why 3S? Well, you have a 3 times height adjustability in the base plate. Usually, if you think about the tile roof situation, the battens, they are usually with a different batten size as well as the thickness of the tiles varies. So you need this height adjustability in many cases. Also, the flexibility to shift from the bracket from the left to the right, from the edge to the edge, let's say, allows you easily to enter in the valley of the tile. The crosshook 3S also has a European technical assessment, so it's certified in all European countries. Additionally, if you also have a situation that the roof in total is not perfectly levelized or imbalanced, we have with the 4S crosshook the option of height adjustability in the bracket. By this you can perfectly align the PV installation on the tile roof. When installing the crosshook 3S, you have to consider on tile roofs like the clay tile roofs to make sure that you create a little gap on the bottom side of the upper tile so that the crosshook can easily run through and perfectly fit below the upper tile. And also you have to prepare and work a little bit on the lower tile as well. So up here to create also here a certain gap to place the crosshook also perfectly below on the lower tile. The same fact you have to consider when it comes to the concrete tiles. So also here you have to create a hole on the bottom side so that you can easily place the crosshook in the center of the tile. You don't have to cut on the concrete tile roof the lower tile. Now I show you how to install the crosshook 3S on a clay tile roof. Now I show you how to install the crosshook 4S on a concrete tile roof. So in case you also might have situations where you don't have enough thickness of the tile to place an aluminium hook there. So we also have, like the single hook Vario for instance, stainless steel solutions, stainless steel hooks, which you can then use in such cases. In case you want to install a solid hook together with the single rail system, with the single rail, we have created the L adapter to connect easily to the single rail. Also, maybe the situation that you have to fix a hook in between two rafters. For this case, we also found a good solution, which I want to present you now. It's the base plate of the crosshook, the crossboard, which you can get in a 2.10 meter rail length, and you just have to cut it to the right length, and depending on the project conditions, and then you install it on the two rafters and place the bracket of the crosshook according to the assembly instruction. As you've planned the project in base, you also get the structural approval of the system, and in the result page you also get the information where the location of each single crosshook is exactly placed. If you use already the Roof Check app, you can also online on the smartphone check out the report information. If you want to get some more information or a better overview of all the different tiles and roof hooks options that are available, then please also check out the video of Olga and Lars. They are showing you there far more of the different roof types.
Okay, good. So universal clamps, they are from 30 to 42 module frame thickness, so they are just clicked inside. We are now developing a new generation of clamps, which will be even easier to insert. So it will be really easy. So I'm really excited about those. Okay, so we said the rafter distance is very important, so you have to know this. I don't know how it is in Estonia. In certain countries it's 1 meter, in certain 700 millimeters. It depends, so you have to tell me. Okay, these are then steel roof hooks. We haven't sold many, if any, to Estonia, so but I have to check if you can even verify them. If they're strong enough. So you see they will be attached from the bottom because they have an elongated hole here. Then another interesting roof hook is this one. This is a special one for flat tiles. Flat tiles you will see on special buildings like government buildings, museums, maybe churches you see. And this roof hook is designed in the way that it sits on the tile, because the tile is flat, So, did you install anything like that before? Yeah? Anybody knows a roof hook? Yeah? Great. So, yeah, that's. Then the next solution is that you might find interesting is the insertion rail. With this solution, there is no clamps. It has aesthetical reasons to use such a solution. You can see the modules are simply inserted into the rail. This solution is a little bit more expensive. I don't know if it's interesting for your market, but Europe-wise, it's mostly sold in Switzerland. It's a little bit more expensive, and there's no problem with money in Switzerland. So mostly Switzerland, no other country. So it really looks nice. And you can see there's no attachment point seen, and it's really inserted inside the rail. Okay. Next one, trapezoidal metal sheet. So this is very important. So we have different solutions here. Some of you have already used them, but in principle, you have two ways of attaching, your solution to the trapezoidal metal sheet. So the first one, which is most common, is just to the metal sheet. You don't go inside the roof structure. What do you need? Because you use here self-tapping screws. So these ones, they just hold to the metal sheet. So very popular, very strong, but you need the right thickness, right? You need the right thickness. Anybody knows what's the minimum thickness for that? 0.5. Okay, 0.5, but what kind of material? Oh, galvanized is just a coating. Steel, yeah. Okay. What if you have aluminum, which is many times the case? You see it, you know. It's more because aluminum is softer, you know. So it's 0.7 if it's aluminum. So it's good to measure this. It works perfectly, but you need the thickness. So what else you need to feed the base in is this thickness, the width, this and this width. So for the solutions that we will talk about, you need minimum 23 millimeters width. So this. And here standard you will see 200 to 33 is more like standard, and these are the main parameters. Okay, so do we have speed rail here, Kalev? No. Do we have multi-rail? Okay. Okay, I have two. You can pass it on. Okay, the first solution you can use, they're free, as I said. Different price, different installation time. And each of them have benefits and disadvantages. So speed rail, as the name suggests, very fast installation. This is the long rail, 5.5, 4.4, 3.3. The software will calculate it for you. Very fast installation. So a team of 4 workers will install, a well-tuned team of 4 workers will install for sure 150 kilowatt of rails per day. So with this system, because it's so fast. So you have the speed clip. So the speed clip is this element, it's crucial. And into the speed clip you insert, you know, the speed rail. The speed clip goes like this. And the rail goes like this. How many of these speed clips the software will tell you. So sometimes you will go on every crest. So this is the crest. So the top. Sometimes on every third. But the software will tell you how many. 90? No. Not here. So this is the standard spacing between the crests. So 20 to 33 millimeters. Yeah. Yeah, it depends on the calculations. So there is no straight answer. So, so how do you start installing this? The first clip goes at the beginning of the rail and the second on the end of the rail, and then you go in between with these clips. So you don't see it here, but every clip has a K2 logo here on top. So you see it, and this is facing the ridge. So this is the ridge of the roof, and every thwart is facing downwards. You have to install like that. I can show you more, just a second. Yeah, so this is speed rail. You can see how they go. So, yeah. You start with the clip always in the beginning and the end of the rail, and then you go in between. What is the thermal separation rule here? You have to separate PV modules after 8.8 meters. So that means if you go portrait with PV modules, you pretty much install 8, connect the rails, and then discontinue because of the thermal separation. And you can see here that there is a K2 logo. Just a second. Right here. Right. So the K2 logo is facing the ridge, and then every fourth is facing downwards and pushed downwards against the rail. Any questions? So you can see here, 1, 2, 3, every fourth, you know, the logo is facing downwards as here on the picture. And it's also pushed downwards. This is the connection rail for the rails. As I said, maximum 8.8, and then you have to discontinue. So you stop connecting the rails, you have to do the thermal break. Torque, so 14 Nm. And there is also a trick. So if you don't want to use the thermal cut the way I explained to you, then you can trick the system by starting with the next rail a little bit below or a little bit above. And the system is still physically separated, but actually you don't lose space, you know. That's why it's called thermal cut space saving method, right? So this you can also do if you lack the space on the roof, because with every thermal separation you lose a little bit of space, and you would just like to squeeze in another row of PV modules. So you do this thermal spacing method. You can see in this case, as illustrated, you know, it starts below with the next one, and then you can save space, but they are still physically separated. So the most important thing is that the rails are physically separated, you know. All right. So this was speed rail. A very important question, you know. Always with each system, this is what I forgot to ask you with the roof hook system. How do you plan it? How do you design it? Do you go portrait or landscape, you know?
Can I ask about the speed rail and the vertical rails? Which kind of rails you are using the new landscape model?
It's the same. It's speed rail. Yeah. You can use the cross bracing with another rail, like single rail, but I don't advise you do that. Yeah, if you want to. Yeah, if you want to go landscape, like here on a facade, you go on the long sides of PV module. So you can use the speed rail the same, but you need a special end clamp for that. Yeah. But the fastest, and this is also my advice to you, the fastest and the easiest is just to design it in landscape. Sorry, in portrait. In portrait. You can go landscape, yeah. But if you can, just go portrait. It's easier and faster. Because if you go portrait, you just have 2 rails. But if you go, like you have a big project and you go landscape, the rail will go along the long side of PV modules. And imagine they will have to work the installer, much more accurately to have the rail in line. Imagine this is a long distance. And if you miss the next rail, just a little bit, the clamp won't grab it. So they have to work with the rope. If you go like this, it takes much more time. It's possible, but if you can, just go portrait in this case. Also, roof hooks, just go portrait as well, because you go just tuck. With roof hooks, if you will go landscape, you will need to do cross bracing. You will need a double rail. So first layer, and then cross bracing, because clamping is here and here. Sorry.
The two rails and landscape, is there any minor things like? Because only thing is you are losing money because you have to build, let's say,
Yeah.
shorter side is 1 meter and you have to do two rails. I mean that in some stations, in some type of roofs, if you have a roof like, like this, you will lose space. Okay, we can talk later.
You're talking about trapezoidal now.
Any roof, like that.
Yeah, with every pitch roof there is a rule what is cheaper. Yeah, and for trapezoidal metal sheet and speed rail, it's cheaper to go portrait. Roof hooks, of course, it's cheaper that you go portrait as well, and this will be illustrated here. Just a second. Here, you can see. This is portrait. You don't need to worry. The rafters are vertical. This means the rail go 90 degrees. Very easy. Here, you have to do a double rail because the span of the rafters will not match the span of the clamping range. So you need the horizontal rail and on top another rail. So double material, more cost. Yeah, so. Okay, so speed rail. Any questions here? Because we move on with another solution, which is mini rail. Look, mini rail is a different solution. You also go portrait here, but this is the original size, right? You have a sealing tape already integrated. It's around 40 centimeters length of this rail. Very easy logistically, that's the advantage. It's all in one box. The rail, the screws, and the clamps. So 3 items, 1 box. Easy for installers. You know, no need of a big warehouse. You can put it into a van. So it has logistic advantages. And it's also cheaper than speed rail because it's a short rail. But you will spend more time installing this because you have short pieces, right? Different holes because you have different distances between the crests. So here, thermal cuts, you know, a little bit later because you have a short rail. You do it after 16 PV modules, right? You do a thermal separation. So, yeah, this is mini rail. So you would maybe pay for this 15% less, but spend 20% more time compared to speed rail. Speed rail I would use, you know, when you have a big project, because installation time is important. So this one is for small and medium-sized projects. Okay. Then with, you know, mini rail, you have different options. You can add 5 degrees by using a mini 5 element, you know, like there. If you go landscape here with mini rail, it's not good. It will take you more time. You have to use a spacer, a jig, because again, if you go landscape, you will have to install 2 rails here and here. And if you miss it just a little bit, if you work without that spacer, the clamp will not grab the frame. So I just advise you go portrait, tuck, tuck, it's all done. Okay. Okay, with every of these solutions, so speed rail, mini rail, multi-rail, you can use the rail up top piece. So this is in case if you have an optimizer, you need more space. It gives you another 60 millimeters. And also, now more and more module manufacturers, they want you to have at least 90 millimeters on trapezoidal metal sheet between the module frame and the crest. So at least 90 millimeter distance because of under ventilation. These modules are heating up, trapezoidal metal sheet, summertime can get up to 100 degrees Celsius. So this affects PV modules performance. And if you look into the document of the modules that you buy, they will specify this. Maybe not everybody, but I saw Longi and all these big guys, they are starting to put this into their manual that you need the distance. Again, this is for trapezoidal metal sheet. It gets the hottest there. So in this case, you will need a rail up top piece. So it's very easy. So you just insert that MK2 into the bottom rail and attach it with the Allen bolt. So this is Allen bolt. Probably in your language, Imbus. I don't know.
Not possible to use with bigger modules also. This rail up pieces.
Why not?
Why not? Your base is the same. Let's say with a 540, 2.3 meter longer side. $1,000.
I've never seen that. It should work. Maybe you mean another system. Here, this shouldn't be a problem at all.
I tried to use that. Somehow it's
Yeah. Never encountered this problem. Okay, next solution is multi-rail. Multi-rail is 25. This is original size. 4 screws, sealing tape. This is a little bit different, Here you go, only landscape. Because this goes not in this direction, but it goes along. It goes along the crest. So very cost-effective solution, quite a strong rail, very popular. Try it out. It really is a good solution. So that you remember, here you have to go landscape because you go here, 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 and here. So, okay. So 3 solutions for trapezoidal metal sheet is speed rail, the long continuous rail, and 2 short ones. So mini rail, portrait, multi-rail, landscape, cost effective, a little bit more time consuming, but that's not the case if you have a smaller project. Right. So logistic advantages, just like mini rail, it comes in a box, so you put it in a van. You don't need a truck to transport to warehouse, like with speed rail, long rail. So plus and minuses for each. Just push it a bit, so it's inside. Same screws, right? Same screws for each of these 3. These are self-tapping screws. Good. We can maybe do an exercise now in K2 base. Do we have a volunteer? Now we will help them. We will invite them here and help them calculate something. So first step, the gentleman will type in the address. As we mentioned, this is Google Earth supported. Right? It should lead you there. So. Yeah, Eurocode. You choose Eurocode for Estonia because, as I mentioned earlier, the Estonian norm is not yet integrated, so you just leave Eurocode and we will enter the wind speed and snow load separately in the next step. But if you click on the design method is slower. Here. Here. Yeah, click on it. Yeah, it will be EE for Estonia when it's integrated. So you leave Eurocode now. And you can switch, you can show to the participants how you switch to the Estonian language. And you go, so you go here. And you change, you go to settings, right? Settings. Maybe there are some mistakes in translation. Then feel free to let us know. Save. And you just go back. I do have to mention in each of your company, there is one administrator. When you register, one will be asked to be an administrator, and this person from your company will award user rights to your other colleagues. So in case you have some issues, difficulties, this is it. You go to the little human being there, to the head. Yeah. And then you have settings. Yeah. Okay, you're ready. You have a project, right? This is just, you name it, but it's important for you, yeah? Yeah. Yeah, but I know what is asked of me, so. Yeah. Now you have to find it and click on it. Do you know which house it is? Okay, click on it. It doesn't do. And then, okay, then just start with the parameters.
Settings to change language.
You have to log in,
Again.
Yeah, but you're obviously not registered. I don't know.
Oh. Yeah. I'm in first. Yes. I made it several times.
You have to use the same username and password
Yes, of course.
as you have when you register.
Yes.
And you have to log in. If you're logged in, yeah, if you're not, if it doesn't allow you, are you administrator? Or if you're not, somebody has to give you the right from your company. Do you have more colleagues?
Yes, I have.
Yeah, then ask if they're administrators already, then they have to give you. Okay, so we are here, 21. This is very important. If you don't know what is asked of you, click on the question mark. Show, please, for the audience. And then it shows you what is asked of you in each of the parameters. Okay? Oh, this is more suburbs. You use suburbs here, right? Yeah, this one. Okay, now, depending on the location, you need to enter the snow load that I showed you in the presentation. Right? Point?
Yes.
You have. Yeah. So, This is again, the category for more for snow. So just use like normal, right? Normal. And then you move on. Which building? I don't even see it. In this case, it will be, yeah. I don't see any obstacles.
Actually, there are 2 windows.
Yeah, we will do that. 2
But
windows.
I don't have the exact measurement.
We'll just do 2, 2 for exercise. Not everything, but yeah. Okay, so next step, you see you have different roof types, flat, single pitch and double pitch. This is a double pitch. And you selected it, and then is the symmetrical or not symmetrical building. So in this case, we have symmetrical. It's like a square shaped, and you choose it, right? Yeah. You don't need to. It's not crucial. Yeah, it's not crucial. The next step is the roof type, right? Is this tiles?
Yes.
Okay, so use tiles. Now, you can still rename it here, so that people know. Just you show to audience that you can rename whatever you wish, and so on. And then you add, right? Add means you will now draw the lines where the rooftop is. You always go roof by roof. So if it's one building, it's not one roof, it's double pitch. You first draw roof 1 and then roof 2. So this will be roof 1. And you always start and you go from left to right along the longest side. So this is the reach, yeah? It will be easier to be accurate, Yeah. So this is my rooftop, number 1. And then you go down. Right? Don't worry about exact measurements. We will now show how you change them, because you have them in your drawing. Okay. So now you show to the audience. If you go to 2D, you go to 2D, right? And you can now change the measurements by clicking on the value and changing them, right? Because you have it here. You don't have that. Then just show them, you click on it, and you just choose something so they see how you change. Like 15 or 14, right? And then you confirm with enter. So drawing is one thing, and the exact measurements will be here. You can do it in 2D, right? Okay. Next. You go here. So show the question mark, what is asked of us. Question mark here. So this is building height, important to know. This is, you have this, yeah, actually.
Yes.
10, yeah?
Yes.
9.9. 9.7, yeah? Okay. And then you have the roof pitch. 30, yeah.
It's not for 45. And we have done, I don't have it exact.
Yeah, 35. I've seen so many that I already can say. 35. Okay. And I will show you what this is. So can you click on the question mark? Okay, this is the direction of the slope. And if you go back to the satellite, yeah, you already have it. But if you click, show to the people how it changes, right? You click here.
Here. Ah, okay, yes.
Yeah, it will change for you, right? And now you go back, right? Yeah. So this is the direction of the slope. Yeah. Yeah. Next is the rafter distance. If you show the question mark that people see. Yeah. So this is rafter distance, quite important, right? Because you need a strong rail to bridge from one roof hook to another. So You don't have this here,
Yeah, apparatus.
but you can estimate. 2.6? So little? Okay. I didn't know there's so little in Estonia. So
on ju või? Sarikate vahekauss tavaliselt 60 ju. Noh, jah.
yeah. Then these are the LATs if you show them, but it's not crucial for this calculation. If you click on it, yeah. Yeah, this is, it's not crucial. This is the LAT, but yeah,
It is.
yeah. Okay, go down. What else? You can leave it because it's not crucial. And you can move on now. We'll do the obstacle, right? So the obstacle is here. If you show now, just for exercise, we made two sky windows, so roof windows. One,
3.9. This.
just draw one, and then we will copy it, so people see how we copy this. Just make one, and don't worry about the position because we will later on change the position. You have to add them.
No, add.
Yeah. Yeah. You can go, yeah, like this. It's okay. Okay, he has one obstacle, right? Either it's a chimney or a roof window, whatever. And now, because he has two, we will show how you copy, right? The second one. And the copy function is here. Just hold so they see. It's right here. Yeah. So he will copy because this is the same. So he needs two, right? Now you will position them, right? From this edge to this one, you have 2.3 meters.
Yes.
Yeah.
How do
Go here.
Yes.
Wait just a second. Yeah.
2.3.
2.3. Yeah, 2.3. And the other one, I don't even see. So
2.3, and this is
it's the
7 tiles. 2
it's exercise. Leave it as it is. Yeah. The level is the same, right? Yeah. Is everybody following, guys? Yeah. Do you use the same address or?
Can you show if we have like this, how to switch like parallel?
Go to 2D. You have to go to 2D
Yeah, it's good to show.
to them.
Yeah, to people. Yeah.
Please show to people where you chose 2D. Say it in Estonian where you showed 2D, but it was a previous step.
I can.
You can say it in Estonian. So it was already previous step. If you remember, right?
Kus siis 2D sai vaadata?
2D. Tell to the people, please.
Here. Siin oli see 2D.
No, 2D, This is 2D, it's not satellite. It was in previous step.
Yes. Do I go there? Or?
Yeah, they want to know. Kalle says they want to know, previous step, where you went to. Yeah, this is, no.
And this is satellite?
This is satellite, click on it. And this is 2D.
Yeah. Et siin saab vahetada, 2D vajutad, siis läheb satelliit. No, niimoodi.
You just, switch back and forth.
ja te saate lülitada nüüd niimoodi mitte sätipildi pealt. Vot, et sedapidi on neid parem peale joonistada.
Okay,
kui te võtate nii-öelda paralleelseks, mitte selle sätipildi. Ja see on see koht, kus te saate valida seda.
And you will show the people ABC how you change the name. But just wait. We are doing this also for them, Yeah. Okay, so change the name now. Obstacle 1. So change here. You can add as many obstacles as you wish, and this is the plus function right there.
So, okay.
Yeah, you have? Obstacle 1,
Yes.
obstacle 2 maybe.
How can I change the name? Where?
What do you want to do?
Change the name?
ABC. Yeah.
Mhm.
Okay, it's okay. Now, what is important with obstacles is the height. The height because of shading. This software will show you where the shade will be, so you will be able, in the next step, to erase PV modules.
So here there is no height because it's.
Oh, it's but maybe you can show them like
20 centimeters.
or half a meter, so that they see the shade. At home, you will do it right. Yeah. Okay. And what is this?
Height and.
Yeah, this is the distance that you decide, but you will see by the shade.
So we're not doing anything there.
You don't need to in this case. Yeah. So, okay, you move on, and yeah, you go to the PV module. Okay, you see, he's now at the step where you have to add PV modules. These lines are rafters, and we will now add PV modules. So let's do that. Either they are in the database. If you can't find them, you have a function user-defined, right? Right here you will click. So show them. If you can't find them, user-defined, you will do manually. Yeah? Here is user-defined. You will enter manually dimensions, but you know. So you unclick, and you choose it from the database. Okay. Just don't bother any because it's an exercise, right? Okay. And you go up. You have everything, yeah.
It's okay.
Yeah. So now you choose the system, right? The roof hook that is in the audience is cross hook 4S, so we can choose this one, single rail.
Single rail.
Yeah, single rail. And you have two options. You say to the software, please cover everything where you can, each, empty space. Or you say, I will, again, design field by field. So we can do both exercises. Let's go first field by field. And you will go one here, and one here. Then you will erase everything, and we will go back to this. Yeah. Parallel, and you go portrait, right? Because it's cheaper, you don't need a double rail. And our colleague will now go field by field. So just so you see, right? Here, place me PV modules here. Okay. The next one in the middle. It has to be plus. You have to add. You have to click add. Lisa. Yeah. Okay, and next one. So this is one option. Because we have obstacle, maybe not the best one. Yeah. So option number one. We will go back and we will redraw, cover me entire roof. So we will finish this one and then go back, okay?
So
now you move on, yeah? You move on. And you go upstairs, a bit upstairs, yeah. You have free fields and you have, you go to PV modules.
What?
Here.
Here.
Yeah. Here there is no thermal cuts here, guys, because it's too short of a roof. And you just go to the results and you go to the
Forward.
Yeah, forward. Okay. Crosshook 4S. So this is the structure verification. You have to have it green. This means everything is okay. My mounting system is strong enough. Plus, when you go to results and you go here, you see you have to be under 100%. Yeah? Okay. Which we are. We are just at the limit. If you are 110%, it means 10% overloaded material. And then you have roof hook and rails. And you can see where it's overloaded. So the software tells you this, right? Okay, good. You have the roof hooks. So these are the black dots. The rails are the blue lines. And then we go to the calculation of the bill of materials. This is next step. You see, you have 28 PV modules, and this is your specification, which materials you need, right? Okay? And even the price, there is a price, but this is just like, yeah. Okay, the layout is not optimal because we went field by field, so we have empty spaces. So we go back. We will do the layout again. We will ask the software to cover all spaces apart from the obstacles. So how do you first erase this stuff? So if you want to erase all PV modules, you go to the wastebasket right here, and it will erase everything, right? And now you start over. But the thing is, you erased the roof. I thought you were here. So you have to redraw it. Yeah. Okay, don't go to K2, you go to K2, right? And then you erase the PV modules by clicking on wastebasket. He'll have to redraw because we made a mistake. Okay, just leave it like it is, no measurements, just 2 obstacles. Go to 2D maybe. You'll have to add the parameters again. You have to add the parameters. Okay. After distance you have 6.
Right, 60.
0.6. Where is the rafter distance?
0.6.
0.6. Yeah. Just add one in the middle for exercise. It's exercise. And leave it in the middle. And that's it. And you move it a little bit to the middle, so we have to in the middle here. Just in the middle. One is enough. They saw how it's done. So you move forward. And now you will choose the entire rooftop. You go to K2. Okay, again PV modules. Yeah. Mm-hmm. Okay, let's move on. Okay, so single rail. And now he will choose entire rooftop. So see the difference, what will happen. The software will, cover every empty space. Apart from the obstacle, of course. Okay? If you go to the below a bit, just you go down with this stick. Just a second.
Oh, here.
Yeah, you have now 44 PV modules. Here, I don't understand. But if you go to show me shading, right? It doesn't show because you didn't choose the height.
Yes, we didn't choose.
So if you choose the height now, the software will show you the shading. So let's put 1 meter just to see, but we will then change it. And now Okay, now it shows you shading, right? So if you have obstacles, you will see where you cannot put the modules. Okay, now you can erase this height because it's a skylight. Okay, and you move on. And now we will show you how to erase PV modules. So if you want to erase individual PV modules, okay, you go to the rubber. You click the rubber first, and then you can choose individual ones. But this is very easy when you have a small project. But if you have 1,000 PV modules, like CNI, commercial industrial buildings, then you can select entire columns by clicking Control and click, or entire rows with Shift and click, right? If you do this, then you have to confirm by clicking on the rubber, right? So, and we go back. If you click on the wastebasket, you will lose all PV modules. So
only the rubber.
Yeah. So use the rubber unless you want to delete everything. And now you move on. Let me see there if there's any thermal separation, but it's not. So no thermal separations because the roof is too small. We said earlier, right? No, not necessary.
No.
Okay. You can, you go there. Unless we missed something. So we have now our project. You know, everything is okay. As you see, we are in green. We're under 100% if you click on results here. So none of material is overloaded. None of materials, we are under 100%. What else do you see here? Here you see the load on PV modules, right? How many pascals? Stuff like more technical stuff, right? And if you go here to rails, depending on which you want to buy and store in your warehouse, you can even decide which ones you want to work with, right, as an installer. So if you change this, like let's say that you want to work just with 4 and 3, you click on them, right? Because they will be in the bill of materials. No, where you see the asterisks, these are old lengths that we don't sell anymore. So just the ones that are without asterisks. So 3.3. Yeah, the software will give you then all combinations, right? But you can also leave one length and the software will work with that, but you will have to do some cutting. Okay, good. So you move on. You go now to the bill of materials. Right? And that's it. So you go now to PDF. So this is your report. Yeah, print it and show it. You click, you show to the people. Yeah? And you close here, this one. You close this. So you have a full view. Yeah. So you go now, you go down. So first page is another one. This is just general text. You always have the parameters that you entered, yeah, here, right? And you go down to the layout. You check the number of PV modules. You check the layout. You see the layout here, right? You go down, down, down. Okay. Here, this is rail cutting guideline, you know. Here you have some rail cutting guideline. You can, you know, take this into account and work by it or work with your own system. This is just a guideline. You can see that a type of rail is 5.8 meters long and that you take, so 1.3 and the second one 2.5, which is cut as an original, and you have a leftover. Sometimes the leftover will be used in the next row and so on. You have a look at this. You might want to work with this, you know, and reuse the rest, the leftovers. So if you go down to the layout, A, B, C, D, E, you will see what is meant by that. So these numbers, show it, are the connected rails length. So, and that's why you have A, B, C, D, E, because it will now show it in the layout. So please go down. Yeah, more you can see here now. These are the lengths. You can see A, B, C, D, E. And this is from the previous table of how you connect the rails and use the cuttings. So E, D, A, C, B, A. So if you go back to the table, you see that it gives you a guideline how to do the cutting and maybe reuse. You can see this cutting here. I don't even see it. Right? Is there any reused? 5.5, 7.4. In this case, left over here. Yeah. It is used. Okay, what's next? Then you have, here are the roof hooks, the position. If you go back up, here you can see. Do we go on every rafter? We don't. So in this case, they are so close together that sometimes every other is good enough. Yeah. Okay. This is then some structural engineering formulas. Engineers will understand this. If you're an installer, you don't need this, but it's for engineers. So you go down to the bill of materials. Okay, more. This is static, structural engineering analysis. This is your layout. This is your bill of materials, right? This is what you need for this project. This is usually the last page. So if you go a little bit upstairs, where you see the Eurocode, more. Just a second, give me. Yeah, here. You can see this is a verified document by Eurocode, so officially everything is all right? If you do this, you're on the safe side. Okay, if you go back to the base now, and here is Excel, so you can, export this material specification, bill of material, whatever you call it, into Excel, and we will show you this. This is everything what we need, it's just an item number plus a quantity. So this is ready to order document in Excel. Yeah. So enlarge. Yeah, that's it. Any questions? You can close it now. Okay, we have 15 minutes. We will do one calculation for trapezoidal metal sheet with a multi-rail. You want to stay or we call somebody else?
I think somebody else.
Yeah, okay.
Should.
Well, you decide who's going to be. Nobody wants to come. So, quick exercise, trapezoidal metal sheet. We need another volunteer. So, We had a gentleman, now we need a lady. Who's gonna come, ladies? Maybe you, because you're so alone and lonely. Well, it's so easy, come. No? Maybe you? Please come. You cannot reject us second time, so please. Do you have an address, a project or something? Does anybody have a project with trapezoidal? Like a warehouse or a workshop? Okay, then just go to the dashboard. Yeah, we start there at the beginning. New project. Don't save. New project, yeah. And try to find it. Otherwise, we can just draw it in the middle of the meadow. But this looks like flat, you know.
Oh, you need
trapezoidal. But we can just assume that we will just assume, make this smaller, we will just draw it in the middle of the woods because the software doesn't know that we are in the forest.
Oh, okay.
Yeah, so you just click here twice, maybe twice. Yeah, and then you start. Where it's red, you use Eurocode. Eurocode. We don't have a building, so we will do it just like in the middle of a field or something. Okay? Okay? Standard parameters, wind speed, snow load. 21. Yeah, this is in the middle of the field, so we choose in the middle of the field. Yeah, this one. Yeah. And 0.75, that won't work for Estonia, so you will tell me where we are. Where is this?
It's 1.75.
Okay, so this is where we will do our building. It can be double pitched, so the third one, yeah. And you will use trapezoidal here. Yeah. And you draw. You can do, I don't know, 40 times 20. Doesn't matter. No? From left to right, yeah. Okay? And okay? And let's go to 2D. We see how big this is. Make it smaller. Now, you will add, you first add the parameters there, then we'll come back.
Okay.
Yeah. So, the building height, you can 8 or 10. This is very usual. Maybe 15. What else? Then you have, what is this?
It means like
the distance between the crests, right?
Yeah.
250. 250. 250. Okay, and here 25. So show to the people here what is asked of you here. Yeah. So this is the crest width. It's very important. So for these solutions, you need at least 23. You know, it's good that you have more. Yeah. Yeah. Okay, and then material. But just put 25 so that it won't bother us later. Okay? Okay, and then the material. 40, this is not crucial. We will not go inside the roof structure. Okay, you can leave 40. And steel. Material, you can choose steel. And the thickness is minimum, which is okay. Yeah, okay. Then you have this. But you go back there to 2D, you know, we were said that we would kormus. Oh no, roof, sorry, roof. Yeah, go 2D, it should show you.
I think something is, because this is Harja Kauko, this is the this is the...
Crest distance, yeah.
Yeah.
It's okay.
Ah, okay.
Yeah, it's okay. So the arrow is, you go, like, make it down. This is actually a building. So the building was here, right? The building was here.
No,
this is
building. This is koormus, it's the load.
This is building.
Load,
and this is roof. So
yeah.
This is one roof, and you make the arrow down, okay? Make the arrow down, and this is by clicking if you go up.
Where up?
You have here, look. You need this arrow, right? Mm-hmm. Yeah. Another one? Okay. And now you can move out to the PV modules. Yeah, this is the slope direction, you know?
Okay.
Yeah. Mm-hmm. This is the slope direction. You can go back to 2D or stay here. And you go, we won't deal with obstacles here. Okay, Kavant. These are obstacles. Maybe here make one like long line. It's like a skylight. So you extend it, you drag it down, and you make it narrow, very narrow. So like this, and you put it in the middle. Yeah. You click on the middle. Yeah. And drag it down. Yep. Okay, make it wider, and then you will drag it down. Yeah, in the middle, from the middle. Yeah. Okay. Okay, and then PV modules. Okay, we will either choose now one of these three: speed rail, mini rail, multi rail. So let's choose maybe multi rail. So we will go landscape. You have it, so full roof, entire roof. Anyhow, only landscape is possible. That's why it doesn't allow you portrait, because physically it's not possible to install like that. And this is a huge project. Yes, so.
I didn't put the dimension for the obstacle.
Yeah,
like,
you can the height. You can change the height to see the the shading, so the obstacles are here. Yeah, and the height is there.
I'll put height, let's say 30 centimeters. Is meters?
No, meters, 1 meter or 3. A very small shading.
Yeah.
If it's 1 meter, it's more. Try more.
Okay.
1 meter. But you have to show shading here. Did it show you? Go back.
Yeah.
Doesn't show much.
It's from 10.
It's okay. This is the worst case scenario. So, but you have height.
Meter.
This is height.
No, this
is height.
This
it's
is
okay.
height. This is the how far it is.
Yeah. Okay. Distance. Okay. Just leave it like that. This is a big project. So, and go to thermal cuts if there are any thermal cuts. No, this one. Okay, and you have this direction and vertical. So you go to vertical. Here it's pretty much okay. Go to vertical. Because the rails, they go that direction. Here's everything fine. Click again here.
Here.
This
Here.
one, yeah. You could move one line further, but it's pretty much okay. Later with the flat roof, I will show you how you optimize the thermal cuts. So let's finish this with the material. Okay. And you use, so she will use the longer rail, 25, instead of just 10, so you unclick. Yeah. Everything is okay. Your project is verified. Let's see how big is this project. You will go to the last step, see the value, the number of PV modules. Here we have different additions. So we talked about rail up, a distance piece, another 60 millimeters. TerraGrief element is for equipotential bonding. If you don't use your green-yellow version for equipotential bonding. So you can add different additions here. So here, by the electric project, you choose how many of lightning protection clamps you need. This is by the electric project. Yeah, where the lightning rod is,
Okay.
Yeah. Okay, then just wait for it to calculate. It's because the project is huge, and then it takes a little bit longer. Edasi? Still not? Something else? Test it. Something is a report that something is wrong, maybe?
It says company. It says like ingredients. Ingredients that forming metal screw.
Okay, I don't know. Why does it? Yeah, here.
I didn't put
The roof.
Building height. It says.
Go back.
Yeah.
Go back.
In the project or in the room?
Building. Building. This is all okay. K2. Then you have everything here. Titit.
I have.
What does it say here? I know what's wrong. Look, you have to. This is one building, right?
Yeah.
And we chose double pitched roof. And you have to design one roof and second roof, right? Okay. That's why it doesn't allow you. It's the rule. So what we can do is erase this and start over. So one roof and second, and we choose just one roof for the whole building. But in effect, it's two rooftops.
Yeah, okay.
So that's why. So it doesn't let us forward. It's good to know. If you choose double pitch roof, you have to draw 2 rooftops. So roof 1 and roof 2. Otherwise, it won't allow you to finish off.
Can
So
I delete it?
yeah, you delete, and we will choose some real building, so that you don't have problems with that. Just delete. Yeah, and let's start over project. But not here. I want you to start with the location. Okay, and you with the mouse, with the scroller, you make it smaller,
Okay,
and
I
we will
do
find
something.
somewhere here.
There's,
No, here are residential. Go to the industrial. That's here, where you were. Here, we'll take this one.
this is pitch roof.
This one.
Yeah,
This
yeah.
one we'll take, and you will just draw one side of the roof. Okay, don't bother with this. Just type in Eurocode. You have and the date. Okay. Then you have to choose the date, and then it should leave you. Doesn't matter which date. Yeah. Just category 3. Category 3 here. And you have 2.
Two.
Yeah, 2. And here you have 21 meters per second and 1.75. And anything else? Yeah, this is because you didn't choose, we didn't choose. We are still on the same address. We have to start with a new project. Do you remember the address?
Yeah.
Okay. Just come to the where we were, and then I will come back to. Are you still with us, guys? We are. You're looking, okay. Any questions here? So we're doing this from start because we found a building, and she's doing this the first time. So do you have any questions? No questions? Okay.
What about this wind speed? What wind speed do we have to choose? Is it average, maximum?
No, this is Estonian norm. Yeah, this is Estonian norm. It's official. Yeah, this is meteorological data, measurements of 10-year averages. But this, yeah, but the software calculates with the safety factors, like 50 and more %. So it's good. This is by Eurocode, yeah. Yeah. Okay, good, very good. Did you click on the building?
Yes, I did.
Go to the project. Let me see.
Because I wanted to.
Go to the project. Let me see project. Okay, everything is good there. I don't know why it's doing this. Step by step, this is okay. Edasi. So this is double pitched roof again. And trapezoidal metal sheet. And yeah. So we enlarge this and we go just roof by roof, one roof and second. You cannot cover like the whole building with one roof. Yep, okay. 10, 15. Yeah, good, very good. Then you have the slope direction. You have to go down. These are the arrows here, yeah? Click. And then we go to the crest distance, 250. We said it's kind of standard, 250. No, 250. 25. So, yeah, 25. 25. Steel. Material is steel. And that's it. And maybe go, if you want an obstacle again, you go to 2D, it's easier.
Here, yeah?
2D is previous step. Kormos. Or there. Or here.
Yeah.
Yeah. We go to 2D, which is here. And here, you can add obstacles. And one, maybe just one in the middle. In the middle. And, oh, not that big. Just like one square, like, just click on it and you will then make it smaller. Yeah, and put it in the middle. Okay. Put it down. Good. Then you can maybe check the 2D.
Again, I'm going to make the other roof now.
This is north. You don't want to go north with
okay.
PV modules.
Yeah.
It's enough, yeah.
Mm-hmm.
Yeah. So the modules. Yeah, here. And then you choose one, Canadian, whatever, Recon. It doesn't matter which because it's an exercise. 400, any PV module. Okay, you will choose multi-rail, a whole roof, and that's it. Okay, so you know how to delete modules. Do you remember this? If you want, you go to the rubber. The rubber is here. And then like control and left click is the column, control. And click, again. Just a second, and now, yeah, this is a row, and the shift, and shift, and click would be the column. But we have to hold it. You have to hold it first. First you hold it. Then close it. First close it. And now, yeah. You just, so shift.
Yes.
Shift, and yeah, you just do this.
Oh, okay.
So you have to keep holding shift, guys.
If it's gray, then it's deleted.
No, you have to confirm.
Okay.
So once you mark the columns you want to delete, you have to confirm with the rubber. So, okay. So let's finish this to the Muset. Okay. Yeah, in 1 minute we finish. Okay, and then you go to the results. You move on. Good. Everything is okay. Your project is verified. Yeah. Just work with 25. It's stronger and it's not confusing for the installer to mix two lengths, you know. And bill of materials. You go to the last step. Yep. Okay, and you have. Good. So PDF. You can print it. And this is the official document. 108 kilowatt project. Okay. Good, so this is, you go down. Same document, so first page is your parameters. You double check if you entered everything correctly. We said earlier, parameters are very important. And you go to the layout. This is for the installer. Okay. Just another one so that you see where the rails are. Okay, more. Yeah, here, if you enlarge, please close this. Click on arrow so that people see how large. So this is your layout, guys. As an installer, you can see where the rails are. So 1, 2, 3, 4, the rails, multi-rail. Very easy to install multi-rail. So no thermal cuts here because the roof is too short in this direction. So
That's it?
yeah, thanks a lot. My colleague came up with a question that's very important for all of us, for you too. And he will explain to you how we solve this problem in K2 base. I felt it was very important because you will encounter such a problem when it comes to roof hooks. So I leave him up to you now just for this, because I showed him how to do this. So.
Ja põhimõtteliselt tegin ühe teist projekti, ma esimest korda kasutan, ja süsteem mulle viskas errori, kahepoolne katus on ju viilkatus, viskas errori, et overload, et ülekoormatud kuskil, kus on kinnitused ja kus need reilid, et ei olnud kindel, kuidas seda lahendada. Ja siis errori nimi oli nüüd inglise keeles cantilever, siis sisuliselt kui näiteks siin see rail on ju kinnitus ja paneeli serv läheb nii-öelda üle mingi, ma ei tea, 50 senti või mingi, siis ta on nagu lahtine on ju. Et ta ei ole kinni ja siis süsteem viskab errori. Ja siis küsisin, kuidas seda lahendada, et siis näitan seda õiget käiku. Ma arvan, et paljudel võib see tulla. Nii, panen lisa. Kategooria linnapiirkonnad. Katusist külg, plaat. Take some time. Okay. Siin ma panen lihtsalt nagu näidiseks näiteks 1 meeter ja ma ei tea, 100 milli. Nii. Edasi.
You can skip that.
Yeah, I think I can skip, yeah. Foot Canadian. Nii, edasi. Nüüd...
First the whole one. It doesn't work and this works. So we want to see the difference.
Ja, nii et ma valisingi selle tärniga märgitud, mis on justkui soovitatud, kogu katus, paralleelne ja vertikaalne.
Okay.
Nii, single rail, jah. Edasi. Should be
You see? So
Yeah.
let's see the result here.
Mhm.
Cantilever.
Mhm.
And the cantilever is okay?
Console, yeah, it's okay. It's okay now.
Why it wasn't earlier?
Yeah, earlier was not okay.
Did you have an obstacle?
I had obstacle.
Well,
I had
let's do
here
it then.
two
Let's do it.
windows.
Yeah.
So, obstacle.
And you have to delete. You will delete later.
I think I can put console.
And add. You have to erase them, and you have to add. Click on add. No modules. The modules are here. And you have to do the
This one, I think.
and you go to back.
Because I had here, I
Hmm.
had 3 rows.
Yeah, an obstacle. Yeah.
3 rows and an obstacle.
And add Lisa. Is there a third one too?
No.
2.
Yeah, but I'll make my roof bigger, so it should be. So 3 rows.
Mm-hmm.
Now,
And this is not an obstacle here.
how can I move this obstacle now?
Now.
Somewhere close. Now.
Mm-hmm. This is almost copy paste now, right?
Yeah, it's copy paste on that too.
Very similar to on your computer. Okay. So full roof. Let's see now. It should be cantilever problem. Let's see. This is the clock you click on. And it's both. It's the, so first you need to change the roof hook and you will still have the problem. So tell this.
ja põhimõtteliselt nüüd on see viga reprodutseeritud, et nii kinnituste osas on siis need mummud on viga kui ka siinid. Et kuskil näiteks siin see osa, et see läheb nagu nii-öelda liiga palju üle, et see nagu ripub nii-öelda see paneeli nagu selle serv. Et see on siis see konsooli pikkus, see viga või siis ülekate. Nüüd ma üritan vahetada ja.
It's hanging part.
Siin ka põhimõtteliselt on näha nagu, et põhimõtteliselt siin ja ühel siinil nagu see paneel ripub, ilmselgelt viga. Et nüüd ma üritan vahetada need kinnitused.
Okay.
Näiteks FreeS.
So the roof hook 4S is adjustable, but that means a little bit weaker than FreeS. FreeS is now fine, but we still have the problem of cantilever. He will solve this now by drawing 2 PV module fields. So
nüüd näed, et siin nagu
we are below now. We are below, but we're still in the red because the cantilever is the problem.
Ei, siis see oli nagu üle 100% oli nagu viga, nüüd 3 S-iga on okei. Aga konsool jah, on endiselt probleem ja nüüd leidsime, et seda saab lahendada nii, et
so we delete.
Jep.
We will now make 2 fields of PV modules. This should work now.
Sedasi, tuleprogramm sedasi. Tekstus, jah. Nii. Kavand. Nüüd siin valin siis nii, et mooduli väli siis mitte terve katus automaatselt, vaid nii-öelda kahes osas. See peaks lahendama probleemi. So lisa, jah.
And you start just like me here. And you say that you will add in the corner. No. You start here. So that you can cover. The corners we will do later.
Put full
to the middle, to the arrow. And copy. So you show copy. So he will copy and we will drag it the same field on the other side. And you come as close as possible. You drag it to it, and to the obstacle. And here as well.
Natkene mudin siin selle, et oleks jah, nagu kaks erilist süsteemi.
So what do we get now?
Let's see. Tulemused.
We don't have the corner modules anymore. But we can. Where is the problem? Problem is the hook now.
Yeah,
so you change the hook.
Yeah, now problem is the hook.
Change the hook. You have to go back. No, here. Here.
Yeah. Jälle 3S paneme.
Yeah.
No nüüd on kõik korras.
So you can see here that we follow up with another hook on the side. So we don't have the cantilever. But if we add here in the corners, we might see if we solve this problem too. So if we add another, you're fine, plus. But yeah. And you will see if you have a cantilever here. And another one, you can copy.
Yeah, copy. Now. Nii, kohe vaatame tulemused.
So this is how you solve, guys. See, now we don't have a cantilever. If it happens, just remember to start drawing separate PV module fields. This is only the case with tiles and roof hooks. Nowhere else you don't have a cantilever.
As I understand, like here we have like two clamps, so that's why. No, I mean two fastenings. That's why it doesn't give error. But in previous time, there was like only one, let's say, dot or clamp.
True. It was hanging too much.
Hanging,
so it cannot hang just. If it's more than 40 centimeters, you will get an error.
Yeah, thank you. Thank you for resolving this problem.
Okay. Do you have a question there?
Would it have been more easy to just leave those panels with a problem?
Leave? Delete. Yeah, this could be also a solution. Yeah, two options. But maybe you need another 4, right? So, okay, we move on with our solutions. So we are now at the metal corrugated or metal wave-shaped rooftops. So I do have to stress this is metal. So if you have asbestos, the cement fiber ones, this solution doesn't work. It's like multi-rail, but on the bottom, as you see, we have a radius. So it's like conical. So you use the solution called multi-rail CSM.
Kas kellelgi on ette tulnud Eestis säärased katusekatteid? Metallist laineline? Ei, see on teine. Just säärane. Ilmselt jah, seda palju ei ole. On küll vahe, et siin kinnitatakse pleki külge. Mitte, aga kiviprofiil ei ole sirge.
So also landscape, as you see, it's pretty much the same product, but it has a radius. This is the regular wave. So you also, I see in Estonia, you have a wave imitation tile. And this is not the right solution. You know, this is a regular wave, but if you have those imitations that I see in the Baltic countries a lot, it's a little bit different. You would use speed rail for that one. Okay, so if you have fiber cement, then you have to use hanger bolts. Hanger bolts. But this is a headache, to be honest. You know, it's really a headache. Usually the roof structure is wooden. Underneath, you know, the lats are too slim, and you're, you know, shooting this M10 or M12 hanger bolt into the too slim lats. You can split them. So these are usually projects that are a headache because the hanger bolts are very big and the understructure is quite slim or old, so it's not easy. You know, usually you would go into the rafters, not rafters, excuse me, purlins. These are the horizontal, also called lats in English, to catch the top of the wave. And because you have to go to the purlins or lats, they are usually too slim. You know, there is a rule that this is M10, so 10 millimeters diameter. When you drill this into the wooden lat, you need at least 6 times width, 6 times the diameter of this one. So if this is 10, we need 60 in width of the lat. This is very rarely the case. So we say we cancel the project because it's too risky. You can split the lat, you know. And this is what this slide talks about. So sometimes software will also show you N12. So we have 10 and 12. So this is even bigger at 12. And in this case, it's 6 times 12. It's 72. And it's very rarely that wooden lats are 72 at least. Usually they're 50, maybe 60. So this last one, previous? This one? Which one? This one?
Yeah, or we usually this roof.
Oh yeah, I'm coming to that.
Okay.
This is a imitation tile, yeah.
Yes, but the last...
This one won't work. No, but it's not about the radius. The problem with such rooftops, these imitation tiles, is that they have levels.
Yes.
You can see. And you don't have the same height here and here. So that's why you don't use actually, you use speed rail. You have to go portrait and use speed rail solution. Just a second, I might have this solution here. No, I don't, but I'll go back to speed rail. Yeah, so for imitation wave tile, please use speed rail and go portrait for this to work. You know. There's a lot of such rooftops in your country and in Baltics, you know, in general. Okay. So when would you also use, you know, this one? You can use it for trapezoidal metal sheet, like we said earlier. If you don't have the width of the metal sheet, so you would use this one. So this one, this adapter is for solid rail, so it's a T-bolt and a nut. It's from the bottom, but we also have the climber, so you can use it with a single rail as well. So yeah, this is the problem. So how would you go here? Portrait landscape for such roofs. Remember, we go into the lats, which are horizontal. So the rails must go vertically and the modules. Any ideas? How would you install in this case? What would be without a second rail? What would be cheaper? Any ideas? Has anybody done this before? You would go portrait, and this is why. So upper picture, if you go portrait, you see the lats are horizontal, and your clamping ridge, you will not catch it. You will need a first rail, which are green lines, and then the top rail. So if you go landscape, you don't have this problem. You just, install 2 rails, and you always catch the clamping ridge. Maybe a quick video. Okay. So go landscape, unless you want to do a double rail. So, some people say, yeah, but I want to go into the rafters. But the professional installation is always on the top of the wave. And if you go into the rafter, you might miss it many times, This is the argument sometimes you get when you say you have to go into the lats, but you have to go landscape for that. And then somebody says, I want to go into the rafters. Yeah, but you have to then do this. You'll miss the wave, the top of it. You will have to do, extra sealing procedures because this is where the water is and blah, blah. So it won't work very well. So. What if you have a steel purlin? So instead of wood, you have steel underneath. Then obviously you have a different rafter screw for steel. And here you don't have these problems, with the width and so on. Here the problem is that these screws for steel are only M8, so 8 millimeter in diameter. And this is very weak. And many times you won't be able to verify them in base. So you won't get through. And in this case, you will send it to us, the project. We'll have to customize this solution a little bit. In such cases, we will use the bridge solution. So instead of 1, because it's only 8 millimeters, we will use a bridge, and we will have 2 screws instead of 1. So, but this has to be calculated manually, not in base. It's customized. So you will send it to us. So this is steel purlins. Okay, any questions? Okay, this is a quick guideline, if you have different screws. So this is for wood. How deep you have to go. You have to go at least 40 millimeters here if you have a steel purlin. Should stick, below the purlin, 20 millimeters at least. And of course, you have to be careful if you have insulation, As an installer, you have to check this because you might have insulation here. So on this picture, you have just a metal sheet and the beam, but many times you have an insulation between. That's important, to choose the right length of the screw. So, such projects are a little bit more complicated. You need a little more time, invested to get all the parameters. How the roof structure is made. Do you have insulation? So it takes more checking, than with others. Okay, so what do you think about bitumen shingle? So I saw such rooftops also here. We have now the solution. It's new. February 23, it's coming out. It's called Splice Foot. So As you see, it already has a butyl tape integrated. So this is for sealing, so that it couldn't, come to water leakage. And you will use 4 screws. Usually you would have to go into the rafters, the big beams, the vertical ones, but since we use 4 screws, I'm told by engineers who develop that we can go also into the boards. So how are these roofs structured? The same as I showed you here. Yeah, here. It's just a different covering, but the structure is the same. So you have usually boards here, boards, and then you have lats, and then you have rafters. So you don't need actually to go with this solution into the rafter, but you will go into the boards, right? So this will be now, actually you can already order it. So we didn't have really a standard solution for this one. Now we have it, so I'm really glad. Hopefully you too. It is possible, but it's more expensive. It's how we have done it so far. So it's like this. But this is more expensive. So this is our solution so far. And this is now a more optimized, cost-effective solution, which will be standard. This, okay, if you go with speed rail, as you said, gentlemen, so you go vertically, so the water can flow down, and you will need, because you will go now portrait, another rail. So this is more expensive, of course, but this is the old one, right? This is the old one, and there's another one, but here you have to look for rafters. Sometimes you don't see it because it's a ceiling. So you have to figure out where the rafters are. So this is even more complicated, but a lot of people did this. So number 1 and number 2, these are old ones. Now this is the real good solution, cost effective. So remember this one. Okay, and go portrait, of course, if you can. Any questions? So did you take the seam clamp, or I think it was here, or is it in box? No. It's there? Oh, it's here. So seam rooftops, I don't know if you have many, but for sure you have. What's here the most important? So you have so many different shapes, This one, this one, that one, this one. I would say this one is the most common. So remember, it's hard to plan it because you don't know which ones you will use, but this one is most common. Most frequently you see it, maybe 2/3 of all projects. And of course, because you have different shapes, you will use different clamps. So remember, there is no penetrations here. So this is the clamp, and it just sits on it, and from the flank side, it's a special screw that pushes and presses against the side of the metal sheet, of the seam. So no penetrations here. So 2 things you need to know when you have a project. What shape you have of all these. Maybe it's the 7th or 8th, I don't know, but these are most common, especially the first one. So the shape plus the width of the seam. And this is here, so this width. Not so much the height, but the width, because these clamps have different opening dimensions. So this is the most important with seam, standing seam rooftops. So how would you plan this? If you imagine the seam, it always goes vertically, so reach to down. How would you go to make it cost effective? Portrait landscape. Who is for portrait? Raise your hands, please. Not everybody. Who is for landscape? Everybody else, or you don't know? I don't know is the third answer. So who is for landscape? Raise your hand. Only one? So remember, the scene goes vertically and the rail goes horizontally. So meaning it's portrait. So if you go landscape, you will do double cross bracing. It will be more expensive. So beside trapezoidal metal sheet rooftops, these rooftops heat up the most. They're very hot. You have to discontinue the rail after 6 meters already. So if you go portrait, you just do 6 PV modules and then you have to discontinue. This is the rule because this really gets hot, And because the rooftop gets hot, our material gets hot and you have to discontinue. So, like I said, the software will show you this. So, okay, so you see we have different clamps, depending on the shape. And you can combine it either with solid rail family or single rail family. So, but you need to check, not every clamp is compatible with each. So this, for example, one is just for single rail. So you can pass it on. Okay. Has anybody done such project before? Can you raise your hands? Yeah? How was it? Which type? The square shaped one or?
I had this double C, standard C, double standard.
This one. This one most standard. Yeah. Sometimes I get a question or a project and people want to elevate the PV modules on such rooftops. It's not possible. Because as I mentioned, there is no penetration, so we can only go parallel here. So. Yeah, and I'm coming to it now. So this is trapezoidal, so triangle system, right? So I sometimes ask, where would you use these triangles? Which type of rooftops? Yeah, I was hoping you wouldn't say that, Yeah, triangles we don't use on flat roofs. We have standard solutions for that. So we would use triangles. Let's say that you have a trapezoidal metal sheet, which is east-west, and you want to go south. You want to reorientate the PV modules towards south, like this, for example. These are all customized, non-standard projects, and we can do it for you. Again, this is not possible on base, but we have a lot of experience, and we can do this for you. In general, if it's not necessary, don't do it because it's costly to elevate. But if you wish, we can do it. The triangles are quite costly. So if you want to elevate, you can always elevate by extra 10 degrees, and you use our standard elements, which are for flat roofs. I will show you this later. So, but the triangles are up to 45 additionally. And they are more expensive than those elements from the flat roof, which I'm coming to now. So, yeah, so we need a lot of parameters from you if we are going to calculate such a project. So we do a lot of non-standard solutions in our company. We also win clients this way because not every competitor of K2 does non-standard solutions. So we do all sorts of stuff, but we need some feedback from you, We need parameters, we need some concept drawings, and then we can do the specification for you. So, just so you don't think we just do standard stuff, so we do a lot of complicated stuff too. So this is what I was talking about. This is actually a flat roof solution that you can place on trapezoidal metal sheets to orientate towards south. Yeah, S-dome small, it's called. It's such a solution. You can see the rail is multi-rail, and on top we just place components used for flat roofs. And this is actually not a costly solution because you have no triangles. You have no triangles, so you can only see it's the peak and the SD, and these two elements are from flat roofs. And this is easy and cost-effective solution. Very easy also to calculate because per PV module you need either ×2 or ×4 elements. So you can see ×2, screws ×4. So it's very easy. We have an Excel and we will send it to you if you need such a solution. So it's called S-DOM small, and it's only used when you go same direction as the roof slope. So you use then multi-rail and S-DOM small. But if you go 90 degrees to the roof slope, then you need a speed rail, and you need, then the system is called S-DOM classic, you know. So this is still S-DOM small. This is another S-DOM small, but on a metal construction, so another non-standard solution. Let me show you quickly. Yeah, so if you want to go 90 degrees, then you would use speed rail. And we will do this for you as well. So, but we will start now with the flat roofs. Any questions so far? This is the
limits to which panels you can use with the
yeah, this is true. This is the case with flat roofs. We're going to talk about this now. Elevated. Yeah, up to 10. The roof is up to 10 maximum. Trapezoidal metal sheet, you mean? Yeah, up to 10. No, this is flat roofs. The issue with larger panels is only flat roofs. Forget about the trapezoidal. Yeah. Okay, so here the concept is different. We touched on it earlier. You see how these things can fly off the roof, you know. Extra caution is advised here, so we'll have a longer discussion here. So we use this wind tunnel testing, you know, by the principle of car industry. And we get reference values, you know, see how the system behaves. So if you calculate correctly, you are on the safe side, you know. One of the things that you need to enter is the friction coefficient in K2 base. So different substrates, surfaces, you know, like bitumen, PVC, most common, concrete, have different friction coefficient, and this influences a lot how much ballast you will need. We know the averages, but we advise you always to measure this because it only takes 5 minutes. This video talks about it. It's very easy, so and to do this. For example, this roof type, you know, this membrane is PVC, right? Synthetic, this is most common. You know, bitumen also, but less, but PVC and bitumen are the most common. So these are the most sleepy membranes, so they have a worse friction coefficient. Worse means lower. And ballast with these membranes would be higher than for bitumen, for example. But it's very easy to measure, you know. And, you know, my colleague in this video is showing how. I know if you are in the offering stage, you know, you just offer, you don't want to measure every time unless you're there at the project site. In this case, just use some averages that I can show you, but if you win a large project, it's pays, you know, off to really measure this, you know. So you take the worst value of all. So in this case, the worst value is the lowest one. Good. Yeah. Okay, so it's a little bit confusing, but we'll clear it up now. So flat roofs, which solution does K2 have? You know, especially people who are dealing with this the first time are confused. So the first division is south-facing system or east-west, right? Okay, south-facing or single dome is S-dome, 10 or 15 degrees. And then you have D-dome, which is double, so east-west. And this is only 10, right? And then you have options here. So we have 3 options for both. Classic, I will explain what all these things mean. Express, and LS, this means long side clamping. Let's talk about this. So these 3 are the same for this one too. So classic on flat roofs means that we clamp PV modules. So you always have portrait here on short sides, right? This is the cheapest because you need 1 rail and the second one here. So 1 rail is shared by 2 PV modules, but you have to clamp it on the short side. This is the most desirable and the cheapest, of course. But the PV module manufacturers have to allow you to clamp on short side. This is not always the case. And if you have to clamp on long sides, you have to go here, which means double the amount of material. So it depends on the module manufacturer. So this is the most desirable. Express means pre-assembled. It will come to you pre-assembled in 80%. So you will have very little work. You will just place them, you know, and clamp the PV modules. But in 80% will be pre-assembled. And LS is long sides clamping. So this is the most affordable. This one would be 20% more expensive, and this one would be 100 more expensive. So this one you use only when you are forced by module manufacturer. It's not us who decide that, but when you buy PV modules, you have to check in their manual whether you can clamp PV modules on short side, because this is standard for flat roofs. But these PV modules are growing in size, you know. But that doesn't mean that they're stronger. The frame is getting weaker, and if you clamp them on short side, but not allowed to, they will bend. They bent last summer. I know a project in Croatia, 2 megawatt. In 2 weeks, the frame bent because they didn't check, you know. They didn't check whether the manufacturer allows them to clamp on short sides. So I'll be extra cautious, you know, when you buy PV modules for flat roofs and check. They have an extra chapter. It's called clamping of PV modules. The software doesn't know whether you can. This is the module manufacturer issue. No, but the software shows you the pressure on the module, and you compare this pressure with what they say, they specify in their document. Because sometimes they say it's not possible, and sometimes they will say it's possible, but up to 1,300 pascals. And then you compare with what you get in base. So it's very risky. So I know now several clients, they now use 2 types of modules. One for flat roofs and one for pitch roof. Because pitch roof, this is never the issue. You always go on long sides. But here, because of the cost issue, you go also on short. So classic is desirable, but please check. You don't know how much money you can lose if the modules bend, but they do bend. So, yeah. Okay, good. So remember, south-facing 10 or 15, D-Dome 10. D-Dome 10, it's now a bestseller. I'm not sure about Baltics, but Central Europe, Southern Europe, they all want D-Dome. Why do you think, when would you use D-Dome? What's the benefit? What's the advantage? Right? Yeah. Yeah, right here. Yeah, more nominal power, because you don't lose space because of shading distance. You can see here in between you lose a lot of space because of shading. Here you don't, because it's like zigzag sort of thing. And in terms of nominal power, you get at least 30% more nominal power. You don't have windbreakers like here, so it's also almost half the price. That's why, yeah, that's why. Also less ballast, yes. Thank you for reminding me. You get, when we will calculate now, you will get less ballast, because they're close to see from both sides. So there are rational reasons, why would you use east-west system as well, You have to check for Estonia, in terms of your energy yield calculation and how it fits you. So, but Europe-wide, this is a bestseller. Okay, a short video. In the video, you will see combinations. One will be express, like pre-assembled, click, and also will be the classic system. Well, you need the jig, so the jig or the spacer, you can work much faster if you set the length of the PV module, so you can start placing the rails. Remember, the rails are speed rails here, very easily without losing too much time. So that's why you need a spacer. Rail connection, so this is for express. So for classic, we used another one. You will see it. Okay, this is don't fix pro set. We will talk about this now. So this is also very important, actually a crucial issue. Yeah, we'll stop here because it's very important. So not all flat roofs are flat. So if you see a membrane, it doesn't mean that it's flat. So we consider flat only to a certain degree. Do you know maybe how many degrees we consider flat and when it's not flat anymore? You're for 6. Who else? I need more opinions. Who's for 5? Everybody else? Speak up, please. I can't. Okay, you're 5. Anybody else? Degrees, you mean? You are 42 degrees flat. Okay, we consider flat up to 3. If it's 4, it's not flat anymore. And I can say from my 10-year and more experience, these things do slide down if it's more. They do. They just do, no matter how much ballast. So in this case, we would then advise you anchoring. Anchors used, it gets more complicated. But more and more, such rooftops with membranes are not flat anymore. They move, they shift, all sorts of stuff, happens. So 3 up to 3 is flat, then it's not flat. Okay, anchors. When anchors are necessary, K2 base will show you how many. So it won't be like under each module, but will be maybe under each third and so on. It depends on the calculation. So these anchors, are sold as a set, not by us, but some other companies. They have a patent on it, and you have to buy them from them. But calculation can be done with our software in terms of how many and so on. So it gets complicated. You have to know how much insulation you have to the beams below. Sometimes you have steel beams. Sometimes you have concrete. You have to choose. They will want to know how much insulation because of the length screw. So screw length. Sorry. And then it is complicated and more costly. So this is MK2. The black element you just saw, it fits every rail of K2, and then just Allen bolt like always. Ballasting, so you have 2 types. So when you have above 40 kilograms per PV module, you have to use these 2 holders, which are called porter holders. When you are below 40, up to 40, it's speed porter. So these are just 2 short rails, and you can place it on it. So you will see in K2 base, how many of these elements the base software will calculate the items for you. And you can place, on these up to 120 kilos, not more, right? So this is speed porter now called, these 2 elements. You can place on them up to 40, and this is porter. This is up to 120. So this is short side clamping. You see, this is a classic system, This is the express system, which is pre-assembled like this, and then it comes to you 80% pre-assembled. So, but it's more expensive, as you saw, 20%. So it's down to you to decide what you would like to have. So. Windbreakers. This is the same screw that you saw, so for trapezoidal metal sheet. So okay. Yeah. What would you like to know? Sorry? PVC? Yeah, any kind of membrane. You have to do it if it's not flat. Yeah, you have to seal it back up, yeah. But you need a roofing company for that, Electrician won't be good enough. You need a special roofing company with experiences with membranes. Yeah, both. But so our calculation is made based on Solmont and CV Lundberg. CV Lundberg is a Swedish company that offers packages with anchors, and Solmont also. And let me show you. I will try to find their document, how it looks like, but it's not easy. Yeah. If you're a roofer, it's easy, but if you're doing this the first time, it's not easy. Oh, finally. Yeah, so our calculations are done either Solmont or Lundberg. And yeah, you have to know what is underneath, the rooftop, so underneath the membrane. So usually, most likely is insulation, like here. Then you have either like a trapezoidal metal sheet sort of thing. That's one possibility. One possibility is concrete below the insulation. And one is timber, wood, right? So a lot of things must be checked, in this case, but you cannot do without it. Because soon you will get a call from investor, this system has moved, and you start over. So it's really risky, Solmont. So these are all packages, You somehow weld this on to the membrane. You see, look. These are old. They don't do this anymore. And they don't do this anymore. This was like first generation. Now they do this plate, They do with this plate, so this would be Solmont. And our connection to it. So this is like how it looks like. And this is our connection to it. So our connection is called Dome Fix Pro. And this is this one and to the anchor. So yeah. Good. Okay, so you have different, roof coverings. So you can see you can have also gravel, right? Gravel. This is also very common, right? So this is not a flat roof. This is just to show you that we can place a flat roof solution on trapezoidal. Should you like that, right? We'll calculate this for you. And this is S-Dome Classic. It's not S-Dome Small, but this is S-Dome Classic. This is flat and it's for bitumen. So D-Dome, so explain this is east and west. And this is, of course, LS, right? You can see double the material. You need 2 rails under each module. You need double this foot here and these peaks double. And then you need an extra rail to connect all the rows. Now the rows are not connected anymore because there is no clamp here and here. So it's double the material. The price would be also double compared to classic. So please double check when you buy PV modules. Okay. Don't fix per set, so we just talked about this. Calculate it for you in base. The number of anchors and also the positioning of the anchors. Okay, then this is a nice example. Some people sometimes ask me, so I added this picture. What if I don't like anchoring or if I don't want to do it? Then you have some tricks. You can do this, right? You have an extra piece and you connect two groups of PV modules above the ridge. But you need to have the ridge, right? Not all roofs have the ridge because sometimes you just have one slope. So you cannot do this. By the way, this element that we added here, this is our idea, but it wasn't produced by us. So this is a local manufacturing workshop. You can do it here anywhere. It's not a standard element, so you do this with a special metal guy, a locksmith or something like that. So this is possible, for example, to avoid anchors, but won't be possible always. So, we have a lot of ideas, but as I said earlier, we need help and feedback from you, parameters. So, okay, Dome Zero. I don't know, this is not a product that I like pretty much. It is for flat roofs, but it is 0 degrees. I wouldn't use it if it's not necessary. So just so you know, we have it, but otherwise just offer 10 or 15. I don't like this product. It's too much ballast. It's usually doesn't make sense to have 0 degree unless you have 7 degrees, but then you have to do anchoring anyhow. So. Tilt-up vento. Okay, so tilt-up vento. When would you use this? Tilt-up vento, many times I get the answer, yeah, it's for flat roofs, but it's not for European flat roofs. It was developed primarily for Arabic rooftops, which are flat, and their buildings are super thick concrete. And these systems, require a lot of ballast. And their buildings, they have such thick concrete walls and roofs. It doesn't matter how much ballast you place on it, it's always going to work. But our European flat roofs, they have a reserve, statical reserve, of how much ballast you can extra place on the rooftop, and you will never be able to verify this product on flat roofs in Europe because they're just too weak or designed in the way that they cannot accept so much ballast. So tilt-up vento compared to standard ones for flat roofs is 10 times more ballast. So if you need this product, so I would use it in a garden, let's say, or but not on a flat roof. You can see you have from 20, 25 to 30 degrees inclination angle possibilities in one portrait or 2 times landscape. So then we move back to we go back to the standard solution for flat roofs. We do also stuff like this. If you have a green roof, right? It's not a membrane of any sort, but you see you either have a gravel or it's a green roof like a soil. We have also proposed to customers ideas or solutions like this, when we have actually fixed the whole system onto concrete blocks. They're not placed there, but fixed with a screw on top. So we would normally just calculate the ballast, and they send to the customer, if it's 1 ton, please distribute this 1 ton among all these points. And this is one such idea where you would do this. This is like a solution, a few years ago when we didn't have anchors or ideas, but what we did, this is a little shop. It's 7 degrees membrane, PVC. So we came up with the idea to lean the whole system against the snow guard. We actually extended the speed rail towards the snow guard, we made another triangle here, and we used another single rail to lean everything against the snow guard. This is the snow guard. So, and the little guys there, you know, the engineers told us, yeah, this is how much our snow guard can take additional force. We gave them this and they said, okay, so we leaned it against it. So to avoid anchors, and by the way, in 2016 we didn't have anchors. They weren't like tested and anything. So as you see, there's a lot of ideas, right? We also have a checklist, but you know, from the base you see the parameters that you need to collect, right? So let's make now some exercise on flat roofs. We need another volunteer. We'll now design, you know. Yes. We talked about it. You have a project, right? Great. Just go here. The mouse, I have to then give you the mouse. You know, this is for the laser pointer. And now you can use the mouse. The Chrome. And you go up here and you will choose new project. You don't need to save anything here. Well, this will be a seaside project, so this will be a lot of ballast, I guarantee you that. If you have, you know, project out in the open or even on the seaside, this will be much more ballast. Right? Oh, this is not an existing building?
Should be.
Oh, okay. Then you have to click on
Yeah,
it.
yeah.
But I think in the beginning. But,
Okay, I'll go back.
or I don't know. It could work also without, but usually I have to click so that you get that locator. Oh, you did. You had it. Yeah. Yeah, so very important is the building height. Yeah. Usually it doesn't let you through if we forgot a parameter, but I think we didn't, so it could be just a bug. This is a roof. You have to mark the roof, you know? Yeah. Okay, yeah, and now it's very important. So building height, inclination angle, of course, very important. This is bitumen. This is parapet height, and this is bitumen. Friction coefficient, yes. Yeah, this is a good question, you know. Yes and no. It's a good question, you know. If you see up to 0.4, let's say, up to 0.3, it helps to reduce the ballast. But then if you have above, let's say, 0.5 meter, for some reason you have more ballast. And I asked the engineers who test this why, and they said that, you know, the wind in the middle of the rooftop starts behaving in a different way in the middle. It's whirling more, whirling. Yeah. So this is how they explain why you would have then more than not, because logically would be less, right? But it starts behaving erratically, you know, like whirling around more. So that's why I'm saying yes and no. Yeah. Slope direction. If it's okay. South is there. Okay, good.
But the thing is that I needed to take one row less.
Yeah. So do you know what this green line is? Just go up, yeah. This will be, yeah, now green line means the modules are facing north. So just go, please, go up a bit. I will try find you this. And this is here. So you have to click on it and say, I wanna them face here. But you have to click here and then click here, you know? Yeah. No, down. Yeah, down. This line. But you have to click again there, yeah? On the line. Okay? Everybody follow these guys. You know, we just changed because the green line was upstairs, and now we moved it downstairs because we want the module facing down. Right? That's all. Okay. Sorry?
There are like 6 rows, but I need 5.
3. There are 6 now.
Yeah, but I need 5.
Yeah, we will delete. You can delete if you wish, or you can just go up, go to modules, modules here, and you shift it. No, you drag it here. You drag the line. You click on the line and drag it higher, the blue line. Wait. Just go here. Here we are. Yeah, here, and try to drag it. And it doesn't allow you anymore. So just, you have 2 options. You go back and you draw it, or just erase the last one. You know? Yeah. So you go to the rubber, where the rubber is. No, here. Kavad, rubber. Yeah. And then you shift and control and left click, or like this, yeah. And then rubber again. Yeah. Yeah, so you can now please enlarge this. Everything is okay, but this will be high ballast values, but not so much. Look, 40 is your maximum, so please enlarge this here or with the mouse. So these are the values, like this is how much you need to ballast. And now we have 2 options. Stay, please. This is in kilos. And if you have concrete blocks or stones or something which are all same weight, you say, I want a quantity, and I will say 3 kilos. And the software will calculate the amount for you, right here. Now we have the amount, not the kilos, but the number of stones. It's the wind tunnel testing. It's how the wind behaved, and yeah. So go back to kilos, and you get the kilos. So yeah. So compared to your calculation with another software, the difference is 1/3.
Such a big difference.
Yeah, you had 90 kilos there, right?
Yeah, over 90.
Yeah. Did you choose seaside?
Yeah, everything.
Okay.
The same. Yeah.
Okay, great. Okay, we will do one example where we have to optimize thermal separation. let's just first go through the document. Okay, first pages are the parameters, your layout, this is the only energy aspect in this document, the system, this is for the installer, you see these distances, AB, you have again the how you connect the rails, right? AB, so 7.9, but different cuts. So we go now to A and B. So you can see A, and B is here. B is here. And, your installer can, follow these if they want, so. And then they see also the ballast. This is very important for the installer, so they know where to place the ballast. And then I will show you one very important table. These are the values. Second. Okay, here. This is a very important table that many investors will ask you about. How much extra weight, additional weight you are placing on my rooftop. So, in this case, we have only one block. If you have 10 blocks, you would have 10 blocks, 10 columns. This is the number of PV modules in one block, and this is the amount of ballast per block, right? This is dead weight. So dead weight in English, so it's including PV modules, mounting system, and ballast. And this is dead weight per square meter. What is here is 0.13 kilonewton per square meter is dead weight per surface, per entire roof surface. So it's less, obviously, because not everywhere on each, millimeter of the surface is PV module. So here you get, of course, more because it's divided up on the whole surface. But here is just those square meters where the PV system is. Can you speak up, please?
There are 23 panels and total ballast is 10,000 kilo.
Well, I think so. Because, let's go back. You're right. This seems to be a little bit strange because 2, 3, 4, 5, 200, 40, 40. Yeah, this is, for my money, around 1 ton, right? So this might be a bug now, a computer bug, For me, it doesn't make sense. I think it's a bug. I have to report this. I think it's 1 0 too much. I have to send this to the engineers because this is a bug, Sorry? Yeah, but it's about ballast, It's about ballast, so... Any questions, guys, here? Okay, so let's do a bit more challenging now. A project, a bigger one. Just need to go to some industrial area. Okay, this is now a serious CNI project, so industrial commercial, right? I want to show you how you optimize, because you will many times faced with that, optimizing the ballast, the thermal cuts.
If you calculate in Germany or somewhere else, what is the wind speed you put there? 21 meters seconds or what's
Yeah, it's different, you know,
what you use?
22, 23, but the highest wind speeds have in Europe has Croatia. They have 60 meters, so it's not possible to install anything there because this is like a tornado. The whole seaside there, it's no installations unless it's on the ground or something like that. Yeah, so we have 60 meters per second. This is enormous. But like Central Europe, average is 22. Yeah. Okay. This would be parapet. This looks like more bitumen.
Here you put bitumen is 0.8, but PVC is usually how much?
Yeah, this looks more like bitumen. Yeah. We will do this obstacle, you know. This is. Okay, let's calculate with SDOM 610, guys. So we will see the difference then comparing it to DDOM in terms of ballast. Entire roof. I will choose classic. So as you see, you have three options as we spoke about. So express, this is pre-assembled option. Classic, the most desirable if it allows you, the manufacturer allows you. And classic LS, this is, of course, long side clamping, as this picture suggests. So I will choose classic. We have SDOM 10 degrees, so this means south-facing system. Okay, I have pretty much here, ideally, placed thermal cuts. These are the thermal cuts where you need to separate the groups, right? We talked earlier, we said that please connect as many PV modules as possible into one block, because you will get lower ballast per group, per block, if you do that. But 7 degrees in this direction is maximum, so 7 rows, sorry, is of course maximum, so up to 7. In this case, it just happened that like these thermal cuts are okay, but sometimes it will cut you here, like just 1 or 2 columns. I will show you how you optimize this. So we could even optimize this a little bit. So these white lines are the thermal cuts. And we have to click on it and disconnect it. And we will place it a little bit to the left, you know. And again, disconnect this one. And this one we can place here. And this one we disconnect here. So this is how you make more symmetric group sizes. It's very important. You will get less ballast. All right, so either you do it with these white lines, clicking and disconnecting, or you just simply say, instead of 7 or 6, which was initially 7, it won't allow you, 6 will, or you say 5. So you go lower, right? And you see now what happened, right? So you play with this until it's really optimal. So 6 for the vertical ones. Then you get even, you know, smaller ones. What if you go with 5? You get even smaller ones. So 7 was pretty much quite okay or optimal. So this is how you optimize thermal cuts. So as an example, right? So remember, your goal is to have symmetric group sizes. Because if you had smaller groups, that's like now, per group, for example, here you have higher ballast because you don't have enough PV modules inside. Remember, they resist the wind as a group. Okay, so let's go back to 7. Let's check now the amount of ballast, right? Well, first of all, we are okay here, we are verified. What does it say here? What does it say here? Can you translate this for me? Just this. Yeah, so this is important, right? In the module manufacturer manual, they will say, yes, if already you can, you know, clamp them on the short side, you can, but only if the pressure is up to 1200 pascals. In this case, we would be above, right? You know, in certain cases, installation manual would say no problem at all. But in certain, you will see, you know, that they will limit it. They will say, yes, but we limit it to this kind of pascals. So, yeah. Okay, so let's play with this. I want you to spot the difference. You know, we have here roughly 25 kilos maximum we have. How much? 40 maybe? No, here 104 and 73 certain spots. But what we actually had, if we had a rooftop which was 18 meters, which is highly likely, you know, how much will this increase the ballast? Pay attention, please. So you pretty much remember how much we had earlier. Now it's already a problem. Look, this gas doesn't get verified. The problem is here, here, here. Yeah, it's a lot of ballast. What does it say here? So
So this is the problem. The problem is the speed rail. And the problem is here. So what does it mean here? Can you translate this for me? What pressure? Speak up, please. Okay. Yeah, but if we go, this is a stronger one with LS, right? Because we have two supports instead of one. This will work for sure. So this is how you test, different solutions. So yes, price is important, but make sure that you're always green and that you have verified project. In this case, don't forget, 140. I think this was actually the case. Because, Porter. We have very bad, combination of factors. So we have terrain category 2, but if we were in 3, now even if we were in 2, but we didn't have 18 meters building height, usually they are 12 to 14, so I think we would get through, also with the classic system. Let's test this, so no LS, but classic. Just a second. Okay, we're fine. So it's a verified project. We just lowered the building height. Quite frankly, 18 meters warehouses, industrial buildings, they're rarely, but it will happen. But usually the combination of factors, it's decisive. Not only one factor. If you have high building height, high building, plus a terrain category in the open, it's a combination, bad combination, right? It's always a combination, so it's not just one factor. What if we compare this ballast with the D-dome? So we have here maximum 108 and minimum like 42, average would be 40. Let's try with D-dome classic, right? Now remember, the difference will be significant. Okay. Yeah. Do you see? The difference is tremendous, tremendous. We don't even need actually ballast under each module, but mostly on the edges and a little bit in between. And these numbers are way, way lower. So make your own calculation, please. See how it fits your energy yield, kilowatt hours with the dome, if you can use it. So.
One rule, one group of panels would be up to 300 square meters. Then you have to meter.
One block of the module can't be over 300 square meters. This is how to say, building
code.
Here is one block.
Yeah,
That should be 1 meter, like walking line.
So how much are they? I mean, they're not much more. Yeah, we can do this. We can see that in the report. Okay, this is one, for example, standard one. This is 15.7 times 11, 11.3, 155 square meters. You said 300, yeah? We will never be above that. You have to do thermal separations. Yeah. Then maybe, yeah, these are maximum block sizes, so I don't think it will be more. Yeah. So we have now time for questions and also do maybe one exercise. So. One flat roof exercise, right? Who wants to do it?
I have a question. If the PV panel manufacturer says that you need to use 6-point fixing, do you have
what kind of fixing?
6-point clamping?
6 point? Yeah, then I wouldn't buy these modules for flat roofs because the mounting system will be too expensive. Doesn't make sense. Why? I'm under this. I don't know why we're pushing so much with these huge PV modules. You have to know that not every module size is for roofs. These sizes are more for ground installations. For rooftops, these are not the right sizes. So. Sorry? Yeah. I would go with standard sizes. So. And also for two guys, to carry, standard size can be even carried by one guy, right? So.
Can I ask, how can I turn this? Because some of these here.
Oh yeah, let's do this example. Okay. We will come back here. On my computer. And you can follow, just copy the address inside. We'll go step by step. Because this is a perfect example where we need to optimize thermal cuts. We will do this now. Please start.
Let's make a new one. Okay.
You just copy the address. Right?
I don't want to see it. This is a new project. This is new one. Here is the address. This is a new project.
Okay.
Maybe we can start here.
Yeah.
Let's say in the wood something.
Just save it, and then go back. It's.
Okay, but I can change the address here.
Then cancel this, close, or save.
I will save.
You open here.
Open here?
Yeah, nobody sees that, except for me. So to see the address, right?
Yeah.
They only see my screen, so
Okay.
just copy the address in my computer.
How should I do it? Copy address?
Just write the same here, because they see this.
Okay.
Yeah.
But I can't write the correct one. What do we need? This is like,
Is it a secret?
Secret, yes, of course. We have to make it somewhere else.
Then make it in
the
Tallinn.
Yes.
Make it in Tallinn, and we will
Yes.
do it in the middle of the meadow or in the forest.
Yes.
But with these sizes.
Yes.
Yeah.
Okay.
Just go to Tallinn, write Tallinn, and you will see where the forest or the meadow is. The meadow, the field.
Tallinn Airport.
Yeah. Yeah. You can use the mouth; it's faster. Yeah. Yeah, it can be here. The software doesn't know if it's an airport or a cornfield, so you can. You know the sizes, yeah?
Yes.
Okay. It's a little bit diagonally.
Yes.
Not too much, not so much.
The 32 rays, just like that.
Uh-huh. Oh.
Yes.
Okay, so you go to parameters. Up there.
Zero, let's say 1 ray. No, it's flat.
Mm-hmm. This one?
Yes, parameter.
Then you scroll to make it smaller?
Bigger.
Smaller, so you see everything, right?
Okay, this is but it's about
Yeah. No obstacles? No obstacles. Okay. Which system do you want? South? Or
rows to the facing to the south, yes? And
yeah.
The south is here. Yes?
Yeah, okay.
So
okay, let's do this.
models, let's say models. What we can use? We can use what do
South facing, classic 10, right?
which is one? Which one is?
SDOM 10.
SDOM 10.
Yeah. Okay, and now whole roof. Whole roof.
Whole roof, yes.
And classic.
Classic?
Yeah, but you have to check, of course, if the modules allow you, right? Yeah. Just assume now.
Yeah.
But this is quite optimal, so it's not like your calculation. Make it smaller a bit.
Smaller?
Yeah, like this. There's not much, there's nothing to optimize here.
Yeah, that's nice, but I used, in my computer, I used...
different. Then make the small,
system.
then which one? Let me see.
Started to use
DDOM Express.
Same.
No, we had classic SDOM.
Okay.
So you used East-West. So
East-West. Yeah, that's why. Okay.
So use here DDOM Express, right?
What is it? Can we choose here distance between the?
No. This is pre-assembled. You can.
Pre-assembled.
Yeah.
But what it is? What is the distance between two rows?
We'll see that in PDF, you know. But look, wait. Okay. So please optimize this. You see, guys, do you follow still?
We got DDOM. This is.
Yeah, but just for the optimization purpose, it's not cool to have these groups so small.
Yes.
You can shift everything, the vertical ones, to the left for maybe one row. So what we need to do, These are too small. We shift the thermal cuts to the left for all three.
2D, yes.
You go to thermal cuts here.
Thermal cuts.
Here, and the vertical. You click on vertical. Okay, so first what you do is click on one
Okay.
or two left. No, you click there, and you turn it on. You turn it on, and then you turn it off. You turn it off on the right. Yeah, and you turn it off on the right, the white one. You have to turn it off.
Okay.
And you do the same with the next one. No. Here.
This one. Two.
Here.
Here.
Can be one. Yeah,
One
one.
on there.
And turn it on. Yeah, and turn it off, the white one.
White one. Okay.
It will be more symmetric, stronger groups. Okay, and now we close here. So this is now more optimal. You could,
this one also.
yeah, for two.
Here.
Yeah, you turn it on, and then you turn it off on the right.
Okay.
So will you close here, and you will see it's much better now. Yeah.
Okay, maybe this is one on
Yeah. Maybe you could do this one too. No. Maybe just this one.
What?
Just
Ah,
the
this
middle
one.
one. Yeah, the middle one. Oh, you have one too many. I don't know what happened. Okay, let's try with the.
He put itself, how to say?
Yeah, turn it on. Turn it
Turn
on.
it off.
Turn it off. And
Put it-
place it here. Yeah.
Here?
Yeah. And turn it on. And turn it off white.
This one.
Yeah. Yeah. Okay. Should be better now. Looking better, so. Yeah.
Okay.
This is already better, right?
Okay. And what is the distance here between the rows? Can we
This is, this is thermal separation, and it's here.
Okay.
You can change here, right? So vertical, right?
This one is 35 centimeters. This is here, yes?
Yeah.
Because we have to have blocks where you can walk.
Yeah. Then you need half a meter.
Yes, at least. Let's say 600.
Yeah. So he's now changing the spacing between the blocks because he wants the maintenance pads.
Okay, much better.
And another one.
And another one also. Here can be 300 maybe. You can
Yeah.
walk. We have measured.
Yeah.
250 is too small. But
This is where it changed, guys, the
30 centimeters.
the distance.
Okay. Or even 400 maybe, or something. And this is east-west.
Yeah. Where are the vertical ones? Is this vertical? What does it say?
This is all vertical. Yes, this is vertical. Vertical.
Yeah, vertical.
6 models. Vertical is 6 models. It means 6 models. 7 models horizontal. Okay.
This was horizontal. Let's go vertical. No. Yeah.
Now it's
Thi-
horizontal.
This one is. This
This
one
one horizontal. This vertical.
Yeah, this one is 7. If not 7, then it's 5, even better. it takes so long. Yeah, see, it's better. Now it's really optimized, guys. So you could also do some work on the horizontal ones, a little bit, but not a lot. Instead of, maybe you could go 6. No.
But we often don't use, even if it's here.
Yeah, 7, 5, sorry.
It's about azimuth is 30 degrees, then 30 degrees from the south.
7 was better. Yeah, so you leave it like that, and maybe you can do this. Look.
What is
this would be now more optimized.
Okay.
This would be better. Okay. Looks much better. Look.
Okay. Thank you.
Yeah. Okay. Thank you.
I got my answer that I used the wrong.
But you used Express, you know.
Yeah, I used the D-DOM, not S-DOM. Therefore, I had East-West, but I wanted to be South.
So, do you want to do another exercise? Do you have questions? So, actually, I've run out of my slides, so. So few questions.
tänane päev hakkab õhtule jõudma. Et kui kellelgi on küsimusi, siis praegu väga hea võimalus kasutada ära Matjast ja midagi katustest, vilkatustest midagi järgi küsida. Et põhimõtteliselt on esitlused läbi saanud. Kellel on, palun?
Okay. How? No. Yeah, this is a great idea. There's a lot of features that K2 is working on. One is this, what you have just mentioned, that you could insert pictures and also AutoCAD drawings. So the team is working on that to add these features, but at the moment it's not yet possible. Yeah, but a lot of people would like to have this. Yeah. Yeah, multi-layer CSM, yeah. Yeah. What is the question? Yeah, if it's not that wave imitation tile, if it's a regular wave. Imitation tile, then you use speed rail. Yeah, speed rail. Yeah, make it bigger for everybody to see. Yeah, can you? Yeah. So this is not the regular wave, guys. This is a wave imitation tile. It's not really a regular nice wave. Speed rail. You go portrait and you use speed rail here. Yeah, speed rail. Let me go back to the presentation. Yeah, so speed rail. Speed rail and this clip, has a foam, a sealing tape, like a foam that compresses, and it will shape itself around this wave nicely to seal it up. This would be the best solution for the imitation, wave imitation type. Yeah, always. Okay. Sorry, just a question. He has a question and we can't hear him. Yeah. Yeah. Yeah, but the rail goes horizontally. That's not the issue there. Yeah. But with the mini rail, it would go along the wave, so it would be vertical. There is this issue. Yeah. So remember, so if it's a standard project, K2 Base will offer you a solution, will give you what you need, but if you don't have a standard solution, we will do it for you. So ask a question. We still have some time. Otherwise, we'll wrap it up here. Speak up, please. I can't hear. To change the direction of the panel of the roof. Which system? Yeah, you can choose on pitch roofs, you can choose landscape or portrait, yeah. Oh yeah, it's the edges. Yeah. Yes, so you mean this, right? So you have to do this by clicking on the edge, right? Yeah, but this is not what he asked me. Just a second. So this is now, look, this is now east and west.
Change the direction. It means that this is east-west and south-oriented, like S-dome 6.1.
Yeah, you see this is now D-dome, but it's more now north-south because we changed this edge. And if we go back the way you had it, you have to click on the lower edge. And then you will have more east-west, right? So you go edge to edge, right? Look, now it's more east-west, right?
He asked that he wants to have like south-oriented means that we have to use. This is like D-dome is for east-west.
Yeah, so.
Mounting, but the S-dome is correct one. This was my mistake also why I asked.
Yeah, so of course we saw it here. You can choose it, right? But here you have different systems. Was that your question? Because here you can change the system. So let's change it, right? I don't see a problem. So unless you had something else in mind, I don't know. Right now you have more south-facing system, right? All right. Yeah. Yeah, you can choose. Yes, you can. You mean the thermal? The software already knows that you're in Estonia. Why? Because you have it here, right? So it gives you the best, the most optimal shading distance. Yeah. So it gives you the shading distance already automatically. Right? Okay, guys, thank you very much. There's no questions. I enjoyed your company. I hope you got some value out of this, And yeah, thank you for your participation today.
Ja täname kõik.